Hello students, welcome once again to TV Math Hub, your trusted mathematics learning platform. My name is Tujomrejendo Vincent, also known as TV, and I'm your mathematics tutor. I am glad to have you all here for today's lesson. In our today's lesson, following our syllabus for senior 5 and 6, we are beginning an important topic in pure mathematics, and that is vectors. Specifically, we shall be focusing on vectors in 3 dimensions. That will be our first topic. Then we shall talk about lines in 2 and 3 dimensions, and after we shall talk about the planes. This topic here is very important because it forms a strong foundation for advanced geometry and analytical problem solving. So it is also highly examinable, so I encourage you to follow every lesson carefully. So I will be uploading a complete series of lessons covering different subtopics step by step. So this means if you are in senior 5 or you are in senior 6, this is the right time for you to stay fully committed and make sure you don't miss any of the lessons that will be uploaded. At TV Math Hub, we offer full mathematics lessons for O-level, A-level, and university. We give step-by-step worked examples. We offer UNEB examination preparation, revision tutorials, past paper discussions, guidance for mastering difficult mathematical concepts. So in case you need any academic support, you need mathematics coaching or guidance in mathematics, feel free to reach out to TV Math Hub through this number here, or else simply send us an email via that one here. So make sure you subscribe to the channel, turn on the notification bell, and share these lessons with your fellow students so that no one misses out. So let us begin our today's lesson, and we shall begin by looking at vectors majorly in 3 dimensions, although we shall first of all give a brief introduction on vectors in 2 dimensions. So let us look at what is a vector. So a vector is simply a quantity that has both magnitude and direction, unlike a scalar, which has magnitude only. So I believe at the moment you know the difference between a vector and a scalar quantity. So some of the examples of vectors, you may talk about velocity, you may talk about displacement, acceleration, momentum, and force. So those are some of the quantities that have got both magnitude and the direction. We talk about the examples of scalars. When you are talking about scalars, you don't need to forget about distance, speed, mass, and time, plus many others. So after understanding what a vector is, let us talk about how do we represent a vector. So geometrically, a vector is represented by a directed line segment, as we can see here. This is a directed line segment from O to A, and algebraically it is represented by a bold lowercase letter or an arrow notation. So we shall be using different notations when we are representing vectors. For example, if you have like A with this tilde here, so this one here represents vector A. So sometimes we shall be using the arrow, which is showing the direction, that is vector AB, or sometimes we use AB, then we have a tilde there. So that is how we represent, a vector. So we are saying if the ends of the line segment are points A and B, then the vector from A to B can be denoted by AB. So remember, in vectors, directions are very important. So you must know where are you starting from and where are you ending. So if our line starts from A and goes to B, then we shall have this as vector AB, and it will be represented by that. But the moment you represent it as vector BA, then this one becomes something else that is different from this. So BA, it means you are starting from point B to point A, but A to B implies that you are starting from point A to point B. So in the 2 cases, you realize the starting point and the ending point may differ. So it is important to write to consider the directions carefully when you are talking about vectors. So as we have seen, we shall be using different notations. One, to represent vectors, we might have these arrows here. You might have the bold letters, and mostly in our notes here, we shall be using bold letters. So whenever you see a bold letter A, that is representing vector A. So that is what is most important, and we can also use the tilde to represent also vector A. So in this book or in our notes, we shall be using different notations interchangeably. So you need a note to forget how to write the vectors whenever you are putting this down. So let us talk about vectors in 2 dimensions. So what are the vectors in 2 dimensions? We shall be saying that these are simply quantities with both magnitude and direction, but majorly in a plane. For example, when you are considering on the ground level. So if you are considering on ground level, you can have a body, for example, which is moving due east, or it is taking due north, that is in the northern direction. So this can be represented using the unit vectors I and j. So the I will be representing the horizontal direction, and the j the vertical direction. So it means if we want to write, for example, that a body is moving due east, then we can use the I, and the I will imply that the body is moving in that horizontal direction. So briefly, this is what we are talking about. We have the j in the vertical, the I will be representing the horizontal direction. However, in the xy plane, these unit vectors are given by, so the I, that is I represents, that is the unit vector I, and it represents 1, 0. That is, it is purely in the x direction. Then the j represents the y, that is the vertical direction, and that is 0 and 1. So it means the horizontal component is 0, the vertical component is 1. So let us look at this. We want to represent a body which is moving eastwards at 10 meters per second. So if we want to represent that in the, using vector notation, then you can say this, if it is moving due east, then it means it is in the I direction. So instead of saying a body is moving eastwards at 10 meters per second, you can simply say a body is moving in this direction, that is 10I. So when you write 10I, then someone will understand that this body is in that horizontal direction. Then we talk about the body moving due north. If it is in the northern direction, then we attach the j to show that it is in that given direction. But generally, you might also have a body which might not necessarily be moving in the vertical direction or in the horizontal direction. So how do we represent the velocity, for example, of this body that is moving north at 60 degrees east? That is not necessarily in the vertical and not necessarily in the horizontal. So how do we represent this? So to represent this, we simply first of all need to allocate this on our plane. So if you have that one there, then you can allocate this. The north is here, the east is here. If I have north there, I have the east, then north you are coming towards east. So it means we have our angle 60 degrees at this given point. So it means this is the north towards the east, so 60 degrees. Now, if it is moving in that direction, so this is where our resultant is, the resultant velocity, which is 5. So the remaining angle at this given point is 30 degrees. So if that is 30 degrees, so then what will be the vertical component of this velocity and the horizontal component of this velocity? So we shall have our vertical component moving towards the velocity, and this will come towards the resultant. So using the idea or the knowledge of trigonometry, should be able to get the vertical component and the horizontal component. So what will be the velocity for the vertical component? So the velocity for the vertical component can be obtained using the sine. So we can say sine of 30 degrees, sine of 30 degrees is the same as the vertical component divided by 5. So that is opposite over hypotenuse, meaning that VH is actually 5 sine of 30 degrees. Then if I need the horizontal, this is the vertical. So if I need the velocity in the horizontal, so the velocity in the horizontal will give us, so this is h, let us maybe use small h here. So the velocity in the horizontal will be obtained by using this relation, that is the adjacent and the hypotenuse. So which means I can have that as v, okay, cos of 30 degrees is equal to vh upon 5. So meaning vh will be equal to 5 cos of 30 degrees. Okay, so with that it would be important here to use, let us use this as v in y and this as v in x to make it not a bit confusing. So this is v in y, this is v in x, so we can maintain that. So this will be v in y, so let us use v in x to make it v in the vertical and v in the horizontal, so that will easily help us to distinguish them. So this is the v in the horizontal, this is the v in the vertical, but the resultant of course is same as if I am interested in the resultant velocity, and this resultant velocity to be written in form of I and j. So how do I do that? So I get the horizontal component, that is the component in the I direction. So what will be the component in the I direction? So the component in the I direction will be 5 cos of 30 degrees. It is in the I, and in the j direction, that is 5 sine of 30 degrees, that is in the j direction. So in that way we can easily write this 5 in this form here. So this can still be simplified to give us 5 times cos, that is root 3 divided by 2 I, then plus 5 times this is a half, this is j. So our velocity can be written in terms of I and j, in terms of I and j, and that will be the way we write that. So this will be our velocity, which is 5 when it is written in terms of I and j. So that is how we can easily write that. So with that, let us also talk about the vectors in 3 dimensions. So when we are looking at vectors in 3 dimensions, these represent the quantities with magnitude and direction specifically in space. So they are expressed using the unit vectors I, j, and k. So for the one on the ground, we are using I and j, but the one for the space, we shall add there the third component, which is k. So I, j, and k. And this is how you can have it represented. So the I and j will be representing the direction vectors on the ground, and the k represents the direction vector vertically in space. So we are saying that I and j are horizontal unit vectors on the ground plane, while k is the vertical unit vector, and the unit vectors in the x, y, and z directions are given by, so this is I, which is z for the x, so the x is the one which is defined, and that is 1, then others are zeros, so that is 1, 0, 0. So we are looking at the 3 components, so that's why we have 3, that is 3 dimensions, so we have x, y, and z. So that is 0, 1, and 0, that is representing j, and k is represented by 0, 0, 1. We can look at an example. If a body, for example, is moving 10 due east, that is in the I, 8 due north, that is in j, and 12 meters vertically upwards or in space, that is k. So instead of writing all of this, you can simply write this as 10I plus 8j plus 12k. You need to note that I, j, and k are mutually perpendicular unit vectors, so they are perpendicular to one another. So we shall talk about some basic concepts in vectors. These are some of the concepts we need to know. One, we need to talk about the position vector. So if you have a point A in 2 dimensions with, for example, the coordinates x and y, then we write the position vector of A relative to the origin to be as OA, or which is given as vector A, and the position vector will be written in the column form, or you put it in terms of I and j. So this is the coordinate form, but when we are referring to a position vector, then we shall always be using the column form, or the format where we have I and j. And likewise, when we are in the 3D, then the position vector will be represented as x, y, and z. Then you can as well have it as xi plus yj, then plus zk. That is how we represent the position vectors. Next, we shall talk about a displacement vector. So if you have points A and B, so your point A is this, your point B is this. So what will be the displacement vector of AB? So the displacement vector of AB will be denoted as AB. We are using tilde, meaning this is a vector, or A to B using the direction, or simply that. This will be defined as, so the displacement vector AB will be defined as OB, that is defining B with relative to the origin, minus OA, defining A with relative to the origin. So this is how we obtain what we call the displacement vector AB. So we get B minus A. You get this minus this. You start with B minus A. Don't start with A, then you subtract B. That will be representing BA, not AB. So how do we deal with that? We get OB minus OA, which is same as getting B. Remember, the position vector of B can now be written as x2, y2, and z2. This was the coordinate form, but now the position vector should be in the column form, or in terms of I, j, and k. So when we are subtracting, we subtract the corresponding components. So you get x2 minus x1, y2 minus y1, z2 minus z1, and what you get will be the position vector. Okay, so with that, let us talk about some few examples. So looking at this, given the following pair of points, find their respective displacement vectors AB. So we are given A as 2, 8. We are given B as 1, 0. So part A, we need to look at AB. So what will be AB? AB will be same as OB. That is B minus A. That is OB minus OA. And this will be same as B is 1, 0. And then minus, that is 1, 0. And then minus C. We shall have the next one, which is this is 1, 0. This is 2 and 8. So this will be giving us 1 minus 2. That is negative 1. And then 0 minus 8. That is negative 8. So this will be the position vector of AB, or we can have our AB as negative I minus 8j. So that would be the position vector of AB. Okay, so having gotten that, then we can look at the next one. That is, we can try now C. This one we can now try it. Then for C, for part C, let us look at that. What will be the position vector AB? As we have seen, AB same as OB minus OA. We shall have our OB as 1 as 0, 2. We shall have our A 0, 1, 3. So looking at that, this will give us 1, negative 1, 2 minus 3, 2 minus 3, 2 minus 3, that is negative 1. So this will be our vector AB. And for that case, this implies that our AB will be now I minus j, then minus k. So that will be the position vector of the displacement vector of AB. So you need a displacement vector. Okay. So this will be the displacement vector AB. So you go ahead and try part B. You go ahead and try part B, and leave your answer in terms of I and j. So that will be what we call the displacement vector. So with that, I want us to talk about another important concept, and that is about the modulus of a vector. So when we are talking about modulus of a vector, we are looking at the magnitude of a vector, and that is basically the length of the vector. And this length here will be a non-negative scalar. So for a two-dimensional vector, vector A, which is xi plus yj, then we can get the modulus by taking the square root. Then it will be the square root. Then you get the square of the components, that is for x and y. Then you add them. So magnitude of A is same as the square root of x squared plus y squared. Likewise, for a three-dimensional vector B, which is xi plus yj plus zk, then the modulus will be same as taking also the square root of this one squared plus this one squared plus this one squared. So that is how we obtain modulus of a vector. We can look at some few examples here, and we understand more about modulus of the vector. We are still in the introduction part, so you need to understand some of these concepts such that when we reach into some of other concepts, then you need to be relating with these concepts here. So we need to look at part 1. We need to obtain the modulus of this vector A. So we are given vector A. Remember here it is bolded, so when you are writing, please put the notation for the vector. So this is 4 and 3. So what will be the modulus of A. The modulus will be the square root of 4 squared plus 3 squared. So this is same as the square root of 25, and that will give us 5 units. So those will be 5 units. Then 2, you are talking about vector B. So what will be modulus of vector B? Modulus, as we saw, it is the square root of now this 1 squared, 5 squared, and 7 squared. So you simplify that. So this will be the square root of 16 plus 25 plus 49. And this should be able to give us the square root of 90. And the modulus of vector B will be same as 9.4868 units. I still emphasize, make sure your answer is to 4 decimal places or above. So that will be our example number 1 about the modulus of a vector. So that one should be in position to get the modulus, because you are simply taking the square root, then you get the components, you add them, right? You square the components and add them. So you will try for me this question 2. You will try for me this question here. So it says given are the points, given the points A, which is 2, 4, and 6, and Q, which is 14, 1, and 10. You need to find the magnitude. You need to find the magnitude. You need to find the magnitude of the vector AB. Okay, this should be B, of the vector AB. So you should be able to try that, because at the moment I'm very sure you know how to get a vector AB. So if you know how to get vector AB, you should now simply get AB, then after that you get the magnitude. So I hope you should be able to try that question there at the moment. Okay, so confirm and see if your answer will be, confirm and see if your answer will be 13 units. So that is about the unit vector, about the modulus of a vector, and I hope you have fully understood how to deal with the modulus. We shall be using some of these concepts here. Please make sure you understand how we are getting all this. Then we want to talk about a unit vector, and we are saying a unit vector is a vector whose magnitude is exactly 1. So if you have a vector whose magnitude is 1, then that vector will be said to be a unit vector. If you recall very well, we were saying I, j, k, these are unit vectors. So if they are unit vectors, then it means their magnitude is exactly 1. You can look at I is of the form 1, 0 for 2 dimensions, or 1, 0, 0 for 3 dimensions. So if you are looking at magnitude of I, then you are looking at this as the square root of 1 squared plus 0 squared plus 0 squared, which is actually still 1. So that's why we say I, j, and k are what we call the unit vectors, because their magnitude is exactly 1. Now let us look at this example. It says show that the vector A, which is equal to that, is a unit vector. So if we need to show that that is a unit vector indirectly, we need to show that its length is 1. So let us look at that. So to show that a vector A is a unit vector, we must show. So to show that a vector A is a unit vector, we must show that its length is exactly 1. So let us look at the length of A. So for A equaling to 3 over 5i plus 4 over 5j, so what will be magnitude of A? So the magnitude of A is same as taking the square root of 3 over 5 squared plus 4 over 5 also squared. So this is same as having the square root of 9 over 25 plus 16 over 25. So when you look at that, that will be same as the square root of 25 over 25, which is square root of 1, and this will give us 1. So clearly, the magnitude of vector A is same as 1, and if it is 1, then what should be our conclusion? Then the then the vector A is a unit vector. Then the vector A is a unity vector, and that will be answered. However, then we need to talk about the unit vector that is parallel to a given vector. So how do we get a unit vector that is parallel to a given vector? So if you need to obtain the unit vector that is in the direction of a given vector, for example vector A, then we obtain that unit vector as getting that vector divided by the magnitude of the same vector. So we shall be using this cap here to represent a unit vector. So we shall be saying that if you are interested in the unit vector that is parallel to a given vector, or that is given in the direction of a given vector, then we get that vector, we divide it by its magnitude, and what we obtain becomes the direction, becomes the unit vector. Okay, so let us see. Find the unit vector that is parallel to each of the following vectors. The first one, we want the unit vector that is parallel to vector 6i plus 8j. So if you want the vector that is parallel to this, then you want the unit vector A, which is same as the vector itself divided by magnitude of the vector. So what is the vector? That is 6i plus 8j. What is its magnitude? The square root of 6 squared plus 8 squared. So what do you get? 6i plus 8j divided by the square root of 100, and this will give us 6i plus 8j divided by 10, which you can easily split to have 6 over 10i, then plus 8 over 10j, which you can also split to give us that. So from there we can reduce this, and this will be 3 upon 5i, then plus 4 upon 5j. So this is what we call the unit vector that is parallel to vector A. So this will be the unit vector that is parallel to vector A. So the next one, is that. So I hope the remaining ones you can try them out. So we can do one about the one in 3 dimensions, but we shall be following the similar procedures. So let us try the one for vector B, and you try the one for a vector R. So for vector B, that is part 2, we are looking at a vector B, which is given as 4i plus 5j plus 3k. So we need a vector that is parallel to that, and that vector is what we call the unit vector. And the unit vector by definition is same as the vector itself divided by magnitude of the vector. So looking at the vector itself, that is 4 plus 5j plus 3k, which we are dividing by the square root of 4 squared plus 5 squared plus 3 squared. So what will this one give us? This will give us 4i plus 5j plus 3k. So this will be divided by, get 16 plus 25. So we have 16 plus 25, that is 41, plus 9, that will be 50. So we have square root of 50. So we can write this as 4i plus 5j plus 3k, and if we divide this can be simplified to be in terms of 50 is same as square root of 50, same as square root of 25 times 2, which will be 5 square root of 2. So that is what we have. So we have 4i divided by 5 square root of 2 plus 5 over 5 square root of 2 into j plus 3 over 5 square root of 2 into k. So looking at this, we can simplify this further by rationalizing. So that is 5i over 5 root 2 times root 2 here, multiplied by root 2 here, plus this is 1 over root 2. So I can still multiply by root 2 here, by root 2 there, j, then again 3 over 5 root 2 times root 2 times root 2 into vector k. So this will give us, so this is 4. This will give us 4 divided by 2. So that is 2 over 5. So this will be root 2 of I plus root 2, that is 2. So that is root 2 upon 2 into j. Then again plus this will be 3 root 2 divided by this will be 5 times that, that is 10 into vector k. So that will be the unit vector that is parallel to the vector b. So the last one, you try that, that is getting the unit vector that is parallel to vector r. So that will be about the unit vectors. That will be about the unit vectors. So here are some of other questions that you need to try out. Looking at what we have so far talked about, should be able to get the vector of a magnitude that root 7 in the direction of that, given that AB is that, you have BC, then get AC. Given that PQ is equal to that, QR is that, you should be able to get PR. So if they are giving you, they are telling you the vector of magnitude, this is in this direction, so you need to find the vector. Actually, you need to find the vector here. You need to find the vector that has magnitude of this and is in this direction, so using the concept of unit vectors. So you have AB, which is same as OB minus OA. So you also have BC, which is the same as that is BC, that is OC minus OB. You have that, but you need to obtain AC. You need to obtain AC, which is same as OC minus OA. So looking at what you have here, you need to first get OC using any of this, because here you have this and this equation. So from these two equations, you can eliminate this OB. Actually, you can eliminate this OB by adding this and this. Then you have OA, then minus OC. Then from here, what do you need? So here, when you eliminate this and this, you realize that you will remain with for example, AB plus BC. So this will give us OC, because this is a minus, this is minus OA plus OC. So this is same as having AB plus BC, and this is same as OC minus OA, but OC minus OA, as you have seen, is actually AC. So in other words, AB plus BC is the same as A to C. So which will be the answer here, because you have AB and you have BC. So this is same as AB and plus BC. So since you have this and this, you can easily get the answer, and that will be the answer. So use the similar relation. So you have PQ, you have QR. So it means PR is actually same as P to Q, then Q to R. So that will also be the same, PQ plus Q to R. So you are moving from point P to point Q, then to point R. So that is what we shall have. So that will be P to R. Now you should be in position to try that. Then this is A to B, A to B, then AC, and you need BC. So use similar relations and you'll be able to get the answer. So the same applies to all this. So from there we shall talk about what we call the vector algebra. So vector algebra, we shall be looking at the vector addition and the subtraction, then plus the scalar multiplication. So when you are adding or subtracting two or more vectors, we add or subtract the corresponding elements. What does that imply? It implies if you have vector A and vector B as this, and you need to look at vector A plus vector B. So when you are adding, we have got the corresponding components, and that is, for example, this and this are added together, this and this are added together. So those that in the I direction and those that are in J direction are added independently. So when you have 3, you add 3 with a 0, that will be 3. You add -1 with a 5, that will be 4. So that will be your answer. Then when you are looking at B minus A, then you are looking at 0, 5. You are subtracting 3, -1. So when you are also subtracting, you subtract the corresponding elements. 0 with 3, that is -3. 5 minus -5, -1, that will be 6. So that will be your answer there. So that is about the addition and the subtraction of vectors. So with that, you should be able to try out. This is what we have actually done. Let me see, was it the same example? This is a different one. So you can now try this one here. This you can try using the similar procedures we have done here. So simply add or subtract the corresponding elements, and that will bring us to what we call some of other examples that you need to try about the magnitude. We have already talked about the magnitude. So see if you are able to try some of these numbers here. Then we have this number here. Given that the magnitude of this is 6, find the possible values of the constant alpha. That you should be able to try. How do we get the magnitude of this? We simply take the square root. So we have 2 squared plus alpha squared plus negative 4 squared. So the square root of that is equal to 6. So this is same as having the square root of alpha squared. 2 squared plus negative 4 squared will give us, that is 20. So this is equal to 6. So this is 4 plus 16, that is 20. So alpha squared plus 20 squared, take square on both sides, will be equal to 6 squared, which is 36. So alpha squared will be same as this 36 minus 20, which is 16. So which implies that alpha is plus or minus 4. So that will be the value of alpha. So after that, then you should be able to try this one here. Find a unit vector in the direction of each of the following. You should be able to try that. In the direction of that, you should be able to try that. So from there, we shall talk about the multiplication of a vector by a scalar. So whenever a vector is multiplied by a scalar, what changes is only the size, but the direction of the vector will remain constant. So we want to look at some of the examples to understand that one better. When you are given P and Q and you need to get 2P, let us look at that. You need 2 vector P. This is same as 2 into vector P, 1, negative 2, and 3. So this will be same as when you are multiplying a scalar into a vector. Make sure you multiply each of these components by that scalar. So 2 multiplies in 1 to get 2, multiplies in negative 2 to get negative 4, multiplies here to get 6. So this becomes 2 vector P. Then 2, if you are looking at 4 vector Q minus 3 vector P, so that is 4 into vector P. What is vector P? Vector P is 1, negative 2, and 3. And you are subtracting 3 into vector. This is vector Q. Okay, so this should be vector Q. And the vector Q is 2, negative 5, and 5. Then vector P is 1, negative 2, and 3. So simplify this. This will give us 8. Multiply each of the components by the scalar. So that will be negative 20. That will be positive 20. Then subtract. Multiply 3 with that. That is 3. That is negative 6. That is positive 9. So what will this one give us? This will give us 8 minus 3. That is 5. That is minus 14. So that will give us negative 20 minus 6, that will be negative 14. 20 minus 9, that will be 20 minus 9. So 20 minus 9. Okay, so 20 minus 9 will give us 11. So that is 4Q minus 3 vector P. So that will be the value for vector, that is 4Q minus vector P multiplied by 3. Okay, so that will be part A. And then part B is yours. You try that one out. So part B, try that one out. So that will bring us to what we call the Coplanar vectors. So what are Coplanar vectors? We shall be saying that the vectors A, B, and C are said to be coplanar if there exists scalars, say M and N, such that you can easily express C in terms of vectors A and B. So that is C is equal to MA plus NB, where M and N are scalars. So if this condition is satisfied, then we say that vectors A, B, and C are what we call the Coplanar vectors. So having looked at that, we shall come to some few examples here. Find the scalars M and N such that C is equal to MA plus NB, given that A is equal to that, vector A is that, vector B is that, vector C is that. And next, vector A is that, vector B, vector C. Then likewise, find the scalars M and N such that this one is true. So what do we do? Let us begin by looking at part 1. Let us begin by looking at part 1. We are given a vector A as 3, 4. We have vector B, negative 1, 2. And vector C is 4, 0. 4 and 0. So we need to obtain the scalars M and N such that C is equal to MA plus C vector C is equal to MA plus NB. That is what we need. Okay, so we need to obtain the scalars M and N such that this one here is true. So for that case, you are given A, you are given B, and you are given C. So simply substitute. So I want to rearrange this such that this is MA plus NB, which is equal to vector C. So what is M? M is a scalar, so it remains A is 3, 4, plus N, B is negative 1, 2. This is equal to 4 and 0. So looking at that, when you are multiplying a scalar into a vector, so multiply it on each of the terms. Which is equal to 4 and 0. So this becomes 3m minus n. This becomes 4m plus 2n. So that is when we add the corresponding elements, and this is equal to 4 and 0. So having looked at that, should be able to realize that for this vector to be equal to this, then these components must as well be equal, meaning 3m minus n should be equal to 4. Then 4m plus 2n must be equal to 0. Then these are the two equations which you need to solve simultaneously. So to solve this, make sure the coefficients are the same. So 3m minus n equaling to 4. You have 4n plus 2n equaling to 0. So let me interchange the coefficients. So such that this is 2 and this is 2. Then after you will do the addition. So this will be 6m plus that is 10m. Then this is minus 2n plus 2n, which is 0. This is equal to 8 plus 0, and that will be 8. So for that case, what will be our answer there? So it means that 10m will be equal to 8. 10m will be equal to 8, and m will be 8 over 10, which is same as 4 divided by 5. So from that, you need to obtain the value of n by using any of the equations. So you have 3m minus n, which is equal to 4. So this is 3 times m, 4 over 5, minus n is equal to 4. So multiply through by 5. So 12 minus 5n is equal to 20. So you can take this, bring this. So 12 minus 20 is equal to 5n. So this is negative 8, which is equal to 5n, giving us the value of n as a negative 8 divided by 5. So you have obtained the values of m and n such that C is equal to, vector C is equal to m vector A plus any vector B. So you will go on and try the same, do the same for 2, do the same for this part here. So for this part here, you are using 2 equations to solve that, but it is always important that after getting the values of m and n, substitute them in the third equation, because here you will find you have 3 equations. So if you have 3 equations, solve for m and n using 2 equations, and after getting m and n, simply substitute m and n in the third equation that you didn't use. So after that, if it satisfies, then that will be the answer. So next we shall talk about another term, that is what we call equal vectors. So what are equal vectors? 2 vectors are said to be equal if they have the same magnitude and direction. So if 2 vectors have the same magnitude and direction, we shall say that such vectors are equal. We have an example here. The vectors, we have R1, which is given as this. We have R2, which is given as this. We need to find the values of lambda, and this is n, not mu. This is n, because we are having n here and n there. So that is what we are given, and we need to obtain the value of lambda and n, given that these vectors here are equal. So since these vectors are equal, then it means that R1, vector R1 is equal to vector R2. That is what we need to know, that since the vectors R1 and the R2 are equal, then it implies R1 is equal to R2. And what does that one imply? Where we have R1, we shall put there this lambda I plus 2j plus 4 minus n. So lambda I plus 2j plus 4 minus n k will be equal to 2 minus n into I plus 2j plus 8k. So the two must be equal. Okay, so for this case, we can easily write this as lambda 2 4 minus n, which is equal to 2 minus n, 2, then 8. So if this is equal to this, what does it imply? It implies that lambda is same as 2 minus n. It means 2 is equal to 2, which is already true, and 4 minus n is equal to 8. So these are two equations. These are the two equations that you obtain if this is equal to that. Now, for that case, since we are interested in n and lambda, let us use any of these two equations, because here we don't have lambda. We would have solved that simultaneously, but it is also easy because we can easily see that here we can easily obtain n. So let us refer from equation 1, equation 2 actually. 4 minus n is equal to 8. So you can take this, bring this, 4 minus 8 is equal to n, and this implies that n is equal to negative 4. So having gotten the value of n, we can now get lambda. So from 1, lambda is 2 minus n, which is same as 2 minus negative 4, which is same as 6. So lambda will be equal to 6. So therefore, you have the values of lambda and the n. So lambda is equal to that, and n is equal to that. And that will be done. So after looking at equal vectors, we shall talk about parallel vectors. So what are parallel vectors is what we first need to understand. So before we come to this definition here, it is important to note that parallel vectors are those vectors that have got the same unit vector. So in other words, if I have two vectors that have the same unit vector, then such vectors are said to be parallel. So parallel vectors, we shall say that if you have two vectors, for example, if two vectors are parallel, then they have the same unit vector. They have the same unit vector. So what does that one imply? That if you have, for example, the vectors, for example, vector A and vector B are parallel, if these vectors here are parallel, then what does this one mean? Then this means that the unit vector of A, that is A cap, is actually equal to the unit vector of B. But what is the unit vector of A? We have seen that we can get the unit vector of A by getting vector A divided by magnitude of vector A. We can get the unit vector of B by getting vector B divided by unit vector of B. Now I want to multiply through by the magnitude of vector A from here. So if I multiply by magnitude of vector A on both sides, magnitude of vector A, we can say that vector A is actually same as magnitude of vector A divided by magnitude of vector B, then times vector B. Now looking at this is magnitude of vector A is a scalar. This is also a scalar. So you're having a scalar value divided by scalar value, which means it will give you a scalar, for example, lambda, then times vector B. So what does this one imply? This implies that if vectors A and B are parallel, then one of them is a scalar multiple of the other. So that is vector A is equal to lambda vector B, where lambda is a scalar. So this lambda is our scalar, which is representing magnitude of A divided by magnitude of B. So where there is this, we are putting the scalar lambda. So in conclusion, we shall be saying that vectors A and B are parallel if you are in position to express one as a scalar multiple of the other. So that is what we need to know about the parallel vectors. But now look at the case if lambda is positive. If lambda is positive, then we shall be saying that these vectors are said to be like parallel, and if lambda is negative, then they are said to be unlike parallel. And however, if lambda is equal to -1, then we shall be saying that vectors A and B are equal but unlike parallel vectors. So those are some of the statements we can use to describe the two vectors depending on the nature of lambda. That is, if lambda is positive, if it is negative. Those are some of the terms that we use. So the next question will be our example. It says the vectors A and B are given by that and that. We need to show that vector A and B are parallel. To show that vectors A and B are parallel, it means one should be expressed in terms of the other. Now, let us look at the solution. Let us look at the solution. So we are given the vectors A, which is 2i plus 5j plus 3k. We are given vector B, which is 6i plus 15j plus 9k plus 9k. So we need to see if this can be expressed in terms of this, or this can be expressed in terms of this. Okay, so looking at that, we can say, so we let A to be equal to lambda B. So we want to see if A can be expressed in terms of B using lambda as our scalar. Lambda is our scalar. So if we are able to get lambda such that A is equal to lambda B, then we shall be able to say that A can be expressed in terms of B, or the vice versa. So let us look at that. What is A? A is 2, 5, and 3. Then what is B? B is 6, 15, and 9. So if these are equal, what should happen? So we have 2, 5, and 3. And before we put the equality condition, let us first multiply this lambda inside. So this is 6 lambda, 15 lambda, and 9 lambda. So for this to be equal to this, what does it imply? It means that these corresponding elements should be equal. This implies that the corresponding elements should be equal, meaning that 6 lambda should be equal to 2. And if 6 lambda is equal to 2, then lambda is same as 2 over 3, which is same as, okay, this is 2 over 6, which is same as 1 over 3. Also, it implies that this 15 lambda should be equal to this 5. And that implies that lambda is same as 5 over 15. But this is also 1 over 3. Also, it implies that this 9 lambda should be equal to 3. So this should be equal to this should be equal to that, this should be equal to that. Which also implies that lambda is same as 3 over 9, which is same as 1 over 3. So looking at this, since the value of lambda is consistent, then it implies that, A is the same as a third of vector B. So A is same as a third of vector B. So if vector A is equal to a third vector B, then clearly we can give the conclusion that thus the vectors A and B are parallel, since vector A can be expressed as a scalar multiple of vector B. Since vector A can be expressed as a scalar multiple of vector B. So that one will also be answered. Okay, so that is our example 1 there. We have another example here. The vectors A and B are parallel. So here we are given the vectors A and B are parallel. So given vector A and vector B are parallel. So if we are given vectors A and B to be parallel, 1, it means A can be expressed as a scalar multiple of B. That should be one fact. Then the next fact is that if A and B are parallel, then their unit vectors must also be the same, because we said here when we are looking at the definition that if two vectors are parallel, then they have the same unit vector. So these should be the two facts. This should be the two facts about A and B, because they are we are told that they are parallel, meaning that 1, vector A can be expressed in terms of a scalar multiple of B, and 2, they must have the same. They must have the same unit vector. Now looking at what we are given vector A and the magnitude of vector B. So we don't have the vector B. So for that case, it means we cannot use the fact that A can be expressed as a scalar multiple of B, because we don't have the scalar. If we had the scalar, we would do that. But since we don't have it, means that option will be out. So the option we are remaining with is the option that they have got the same unity vectors. So that is the option that we shall use. So given A and B are parallel, then the unity vector of A must be equal to the unity vector of B, because that is the only option we are remaining with. So if that is the case, can we get the unit vector of A? The unit vector of A is vector A divided by magnitude of vector A. Our vector A is 4i plus 12j plus 3k. So we are dividing this by the square root of 4 squared plus 12 squared plus 3 squared. So this is 4i plus 12j plus 3k divided by, so let us get that one there. So that is 16 plus 144, then plus 9. So this will give us 9. So it will be 169. Square root of 169 is 13. So that will be the unit vector of A. Then how do we get the unit vector of B? The unit vector of B is same as vector B divided by magnitude of vector B. Looking at what we need, we actually need vector B. We have the magnitude of vector B. So in other words, we can say that the unit vector of B is the same as vector B divided by 26. So this is what we know. Now, but we have this fact here that actually the unit vector of A is same as the unit vector of B. So what does this imply? So from equation star, it implies that the unit vector of B is also 4i plus 12j plus 3k divided by 13. From equation star, we should be able to give this conclusion. Now, from equation number 2, we should be able now to say that 4i plus 12j plus 3k over 13 is actually equal to vector B over 26. Our interest is vector B. So I hope that one is clear. We have unit vector of A as this one here, but we know that the unit vector of A is equal to the unit vector of B. So which means that if this is the unit vector of A, then it will act as the unit vector of B. But we know that the unit vector of B is same as getting a vector B divided by magnitude of B, which is 26. So which means if the unit vector of B is this, and the unit vector is equal to this, then this one here must hold. So that is why we have this. Now from here, we can now multiply by 26 on both sides. So multiply 26 here, multiply by 26 there. So this implies that by 13 is 1, this is 2. So we shall have 2 into 4i plus 12j plus 3k, and this will be equal to vector B. So this implies that vector B is actually same as 8i plus 24j plus 6k. So this will be what we call the vector B. So when you look at vector B and vector A, what was vector A? Vector A was this. I hope you should be able to see that A and B are a bit related, because this is 4i, 12j, 3k. This vector A, I want us to appreciate this. We are having vector A as 4i, 12j plus 3k. So looking at this one here, you realize that you can express a vector A as a scalar multiple of vector B. Because this is 8, this is 4, this is 24, this is 12, this is 6, this is 3. So which means that vector A is actually a half of vector B. Or else you can say vector B is 2 times vector A. So when you multiply in this one by 2, you get this. By 2 here is 8, by 2 here is 24, by 2 here is 6. So clearly you can see that. Also the other condition will now be satisfied. That is for expressing one in terms of the scalar multiple of the other. However, that won't be helpful when now we are solving for vector B, because we don't have the scalar, so we can't easily get the vector B. So that's why now for this case, this one here is very helpful. This one here of unit vectors, that one becomes very helpful. So that is about the parallel vectors, and after that we shall look at what we call the collinearity of vectors. So when do we say that the given vectors are collinear? One, if points A, B, and C are collinear, then the following must be noted. The first one is that you should be in position to show that either AB, AC, or BC are parallel. So if you have points A, B, and C, so you should be able to show that either AB, AC, or BC are parallel, and you know the condition for parallel vectors. Two, you should be able to show that there is a common point both on the left hand side and on the right hand side. For example, if you want to show that A, B, and C are collinear, then you should be able to have like AB is equal to KBC, and for this case B is your common point, so there should be a common point. So if you are considering AC and another one, then there must be a common point. So when you are looking at your vectors, there must be a common point on the left hand side and on the right hand side. Now let us look at some few examples. ABCD is a parallelogram with coordinates A, B, and C. We need to find the coordinates of D. Okay, let us look at that. So what are we given? We are given A, which is 2, 4. We are given B, which is -1, 5. We are given C, which is 4 and 8, but we don't know the coordinates of D. Okay, but those are the ones we need, and we are dealing with a parallelogram. Now let us see how best we can get that. We shall come to the parallelogram in details. When we are talk about what we call the application of the scalar and dot product. So, but at the moment, the parallelogram has got this side is parallel, and this side is also parallel to that, and also they are equal. So if I have A, B, C, and D, then these lines here, as we shall see in the properties for parallelogram, these sides here are equal. So if these sides are equal, then it means also the vectors AD should be equal to BC. Vector AD should be equal to vector BC. But our interest is to get this. This is XY actually, and this one here is 2, 4. This one here is -1, 5. This one here is 4 and 8. So from position vectors, as we had earlier seen, this displacement can be obtained by getting OD minus OA, which is equal to OC minus OB. Our interest is in D, so we can have OD as, bring this one to the other side, OC minus OB plus OA. So meaning that our OD is actually OC, which is 4, 8, minus OB, which is -1, 5, plus OA, which is 2 and 4. So using the addition and subtraction of what we call the vectors, then we should have this as 4 minus -1 plus 2. We should have this as 8 minus 5 plus 4. Adding and subtracting the corresponding components. So this will be, this is 5, 7, this is 3, this is 7 still. So this is our OD, and what implies that D is actually 7 and 7 and 7. So that will be the coordinates of D. Another part requires us to find, okay, that is question 2 now. So we are given the position vectors of A, B, and C. That is OA, OB, and OC. So we need to prove that A, B, and C are collinear. So we have seen for collinearity, then should have like AB is equal to KBC. There must be a common point on both sides. So let us see how we can prove this. So we have OA 1, negative 2, 2, OB 3, 2, negative 1, OC 7, 10, negative 7. So we need to prove that AB and C are collinear. So let us look at that. So we are having, or we are given OA as 1, negative 2, 2, OB as 3, 2, negative 1. We are given OC as 7, 10, and negative 7. That is what we have. We need to show that. We need to show that. We need to show that A, B, and C are collinear. And from the conditions given, A, B, and C will become collinear if we are able to express AB in terms of BC. So if we are able to get lambda such that AB is equal to lambda BC, then we shall say that they are collinear. So let us try to get AB. So what is AB? Vector AB is OB minus OA. But what is vector OB? Vector OB is 3, 2, negative 1. Vector OA is 1, negative 2, 2. So the corresponding entries we shall get 3 minus 1, 2, 2 minus minus 2, 4, negative 1 minus 2, negative 3. We shall have that, 2, 4, negative 3. We shall have BC. What will be BC? That is OC minus OB. What is OC? OC is given there. OC 7, 10, negative 7. OB, that is 3, 2, negative 1. So what will it give? It will give us 4. This is 8. And this is negative 6. So let us see if we are in a position to get lambda such that AB is equal to lambda BC. Now, so let us look at that. So AB, for AB equaling to lambda BC, let us see if we are able to get lambda. So lambda must be the same for it, must be consistent for you to conclude that. However, in case you are able to get different values of lambda, then it means it cannot be expressed in terms of the given expressions. So AB is, our AB is 2, 4, negative 3, 2, 4, negative 3. Our BC is 4, 8, negative 6. So which implies that we shall have 2, 4, negative 3. This is 4 lambda, 4 lambda, 8 lambda, negative 6 lambda. So, but what does that one imply? This still implies that 4 lambda will be equal to 2 when I equate this with this, implying that lambda is a half. 8 lambda will be equal to 4, implying that lambda is a half. Negative 6 lambda will be equal to negative 3, implying that lambda is a half. So we realize that lambda here is consistent, since a lambda is equal to a half and is consistent. Then it means that AB is actually a half of BC. So with that, you can easily see that we are able to express AB in terms of BC, or which you can have as BC is equal to AB when you cross multiply. So you are able to show that. So if you are able to show that, then we can easily say that since AB is equal to a half BC, or BC is 2 AB, then actually before that, and you can see that B is a common point, and B is a common point, and B is a common point on both sides of the equation. On both sides of the equation, then points A, B, and C are collinear. So with that, we shall be in position to prove that A, B, and C are collinear. So that will be well answered. Okay, let us look at the next one. So the next one will be your trial question. So try and show that the given points are collinear. You should be able to follow our previous example and you try out that one. So for our today's lesson about introduction to vectors, we shall look at the last part, and that is about the ratio theorem, or what we call the section formula. So I want us to consider the division of a line AB by a point P as shown below. So here we are having point P, which is dividing the line AB, and we shall be saying that P is dividing this line here internally. P divides the line AB internally. So that is within A and B. So if we have the line A and B, and P is dividing this line internally, then what will be the ratio of A to P and P to B? So A to P, we look at the number of divisions here. So here we are having only one division. From here up to this given point, we have 1, 2, 3. So there are 3 divisions. So in total, we have 4 divisions. So if P divides AB, then we shall say that the ratio of A to P, from A to P, and P to B, and P to B will be same as 1. It is only 1 to 3. That is 1 to 3. So that is how we can write the ratio. So whenever we are talking about a point dividing given maybe a given line, then you look at A to that point, then P to the other point. So we are looking at AP to PB, which is 1 to 3. But depending on how divisions, or how many divisions you are having, then these ones can be changing. It can be 1 to 2, 1 to 3, 2 to 3. They depending on the divisions you are having. But for our case, if P is dividing this line in such a way that we have 1 division here and we have 3 divisions here, then we can write that AP to PB is 1 to 3. It is very important when it comes to the ratio theorem, the direction, to note the direction. Very important to always consider the direction. So if we are taking A to P to be our positive direction, then it means P to B will also be in the same direction. So for the direction of AP and PB is the same, so we maintain positive values here. But let us look at another scenario, that is another case. So what if P divides the line AB from outside, that is externally. So if P divides AB externally, then we shall be having, because we are having our line A to B, but P is dividing this line AB externally from this point of A. We shall have 2 cases where P will be this side of A and P the other side of B, because it is possible for P to divide AB from the other side of B or from this side of A. But what will be the difference there is what we shall be talking about. Now, if P divides line AB externally in such a way that you have P on the side of A, then what will happen? So if P divides AB such that this one here becomes, for example, 1, A to P is 1, and P to B is 4. So there are 4 divisions, 1, 2, 3, 4. So if from here to here we have 4 divisions, and from here to here we have only 1 division, then it means from A to B we shall only have 1, 2, 3 divisions. We shall have only 3 divisions. Now, if P is on the side of A, then AP will be smaller than PB. So if you are given the ratio that P divides the line AB in the ratio of -1 to 4, P divides the line AB, A to B, in the ratio of -1 to 4. The -1 is placed there because of the difference in the directions. When you look at A to P, then you also look at P to B. You realize P to B is in that direction, A to P is the other direction. So the negative is always placed either on 1 on this value or this value, just to cater for the difference in the directions. So whenever you are having maybe a given point divides this one in the ratio and you find it is -1, for example, -1 to 4, then that is an external division. So always put the negative sign to show that P divides maybe that line externally. If it is internally, all of them will be positive. If it is externally, one of them will be negative. So the negative can be here, the negative can be here. So the choice of where it is has no impact on what will be your representation. Now, we are saying if P, because it is always, the ratio that is given is always in the form of AP to PB, is always in the form of AP to PB, provided P divides the line AB, whether internally or externally. So if it is internally, then it is still in the ratio of AP to PB. If it is externally, still it is in the ratio of AP to PB. Of course, we are taking A and B to be our general point and P. Now, of course, these ones can change. They can bring M and N. But still, if they say P divides the line M and N, then it means we are talking about M to P, then P to N. You are talking about that. So if you are given such a ratio, that is 1 to 4, then how do we locate the P towards A or towards the other side of B? So if this one here is -1, maybe to 4, so this corresponds to AP and this corresponds to PB. So when you realize that this one is smaller than this, then it means P is on the side of A. So that is where we shall place the P. Now look at the case where they give you that P divides the line AB in the ratio of 2 to 3, where one of them is a negative, maybe that. So if you are interpreting this is A to P, then this is P to B. So A to P is taking 2 divisions, P to B is taking 3 divisions. So if you realize that A to P is smaller than this, then it means on your location, when you are locating P, you first put your AB, then the P will be this side towards A. That is where you will have your P. So it means this will be A to P will be 2, then P to B will be 3. If you place it this side, it will become wrong, because look at this case, you are having A, B, but for you have interpreted and you are saying that P will be this side. So what will happen? If this one, you are saying A to P is taking 2 parts and B to P is taking 3 parts. So by interpretation of this, so you realize 3 parts are contained within 2. That one is impossible, because from here to here cannot be 2, and from here to here it becomes 3. So that's why we are saying when you are given such a ratio, first look at which one is the smaller. So it means the P will be towards the one which is smaller. So that is how we locate that. Then after locating this one here on your diagram, you have P there, you have placed your A there, you have placed your B there. The negative is always there to show you that the directions are different. But when you are putting it here, don't consider this and put -1 here. That one will become wrong. So the negative is simply to show you that the directions considered are different. So it means now, if I write here my A to P is 1, then my P to B is 4. As I said, you interpret this as A to P, P to B. A to P, P to B. So it means my P to B is taking 4 parts. A to B will now take 3 parts. So from here you can get different ratios if you want. So not necessarily using even the one that is given. So from here you can have, for example, P to A and A to B. What is P to A? P to A and A to B. A to B. So what is P to A? P to A is 1. A to B is 3. You can also use this ratio. This ratio will give you the same answer as someone who uses this one or someone who uses this. So as we have said here, AP to PB is -1 to 4. You can also have it as AP to PB 1 to -4. So where the negative is, whether it is on 1 or -4, it does not change anything. So it remains the same thing. So the negative can be here, can be here, but this expression will remain the same. Okay, so we shall understand more when we are looking at examples in that regard. Now the last case is when P is the other side of B. Here P was towards A. So when P is the other side of B, then it means that A to P is bigger than P to B. That is what it means. So when you have, for example, 4 to 1, if you have they tell you that P divides AB in the ratio of maybe -4 to 1, because it has to be minus since we are dealing with external. So if they tell you that a P divides A, B in the ratio of -4 to 1, when you are locating that, this ratio implies that this is A to P, this is P to B. So it means P to B is 1, A to P is 4, is taking 4 parts. So if this is your A, this is your B, then P should be towards the one which is smaller. So P should be at that side of the one which is smaller, that is P. So this one here is 1, but A to P is the one which is 4, which means the remaining part here is 3. But when you put P this side, when you put P this side, and yet they are telling you AP is 4, and 4 is bigger than 1, then you will get something wrong, because that will be the same scenario as we have seen up there. Because if this one, if you put P here, look at this, from here to here you are saying it is 4, and from P to B is 1, from here up to this given point is 1. That one is realistically wrong. So it means you have to be careful. So look at the ratio which is given and now determine where the point P will be. So the point P will be towards B if, of course, you are given like 4 to 1, 4 to -1. It means the first value represents AP, the next value PB. So you realize that this value is bigger than this, and for that case, then P should be the end of B. Then when it is the vice versa, 1 to 4 or 1 to -4, it means AP is now smaller. So it means P should be in the side of A. So that is how we determine the location of P, especially when they talk about the external division. So they are saying A and B are 2 points on the line. A point P divides AB in the ratio of 1, part A, 2 to 1. So let us look at part A. You are having the line AB, but your A is 3, 2, and your B is -1 and 4. Then they are telling you that P divides AB in the ratio of 2 to 1. If there is no minus, it means it is dividing this internally. Okay?
Yes.
So I will put this P somewhere here. So I don't know the coordinates for P, so I can have it as XY. Now, since this is internal, then they are saying that in the ratio of 2 to 1. So it means A to P is 2, then P to B is 1. So for that case, now you can say this A to P. So here, this P divides this one internally. So this is dividing internally. So from this, we can say A to P and P to B is the same as A to P is there are 2 divisions. This one is 1. So what does that one mean? We can now have this one as ratios can be put as fractions as well. So AP to PB is same as 2 divided by
1.
By 1. So this implies that AP is same as 2P what? 2PB, isn't it?
Yes.
We have our A, we have our P, we have our B. So what will be AP? That is OP minus OA, which is equal to 2 into OB minus OP. Your interest is to get P, coordinates of P. So I can have this as OP minus OA, which is equal to 2 OB plus 2 OP. So can we collect, this is a minus. So we can collect like terms, bring this 2 OP this side, it becomes 3 OP. Take this one the other side, it becomes 2 OB minus plus OA. So what else there? We have 3 OP, which is equal to 2 OB plus OA. So let us have this as 3 OP, which is equal to 2 OB. What was OB?
OB is
OB -1, 4. Then the other one is 3, 2.
3, 2.
So this will be That was the
negative 1, 4.
negative 1, 4. Plus 3, 2. So 3 OP will be equal to negative 2, 4
2
plus
plus 32.
3, 2. So this will give us 3 OP, which is equal to
1, 6.
1,
1, 6.
1 and 6.
Yes.
So OP will be equal to, divide through by that. So OP will be equal to
A third.
a third and
1 over 9.
1 over
1 over 18. 18.
Oh, we made a mistake here. We multiplied 2 here, but we forgot to multiply it here.
Oh, yeah.
So this should be
8.
This should be 8, which should give us
10.
10. Eh?
Yeah.
So this is 10. Now this a third here, this a third. You don't multiply 1 with 1 and 3 with this. This is a third, which is a scalar multiplying into this and this. Okay? So don't multiply this as if you are multiplying 1 with 1, because this is not a vector. This is a scalar. So multiply a third with 1 and a third with 10. Eh? So this will give us a third and 10 over 3. So which means that P will be a third and 10 divided by
3.
And 10 divided by 3. So that will be the value of P.
Okay.
So okay, so we can start. I hope my speech is very clear.
Yeah, it's clear.
Okay. So yesterday we were talking about the ratio theorem, where we basically looked at 3 cases. The first one was when a point was dividing internally at 2 given points. And we looked at another case where we are having a given point P dividing AB externally. So there are 2 cases. This is the second case. This was the first case for dividing externally. So looking at this case here, you realize when you place P this side, P to B is the one that becomes bigger compared to P to A. So it means if you have, for example, a value where you have like 1 to 4, but one of which one is a negative, then it means if you are describing, for example, in terms of AB, it means point P will be to near point A. So when you look at this is 1 to 4. First of all, ignore the negative. So when you look at 1 to 4, it means that P to B must be greater than A to P. So for that case, it means that P should be nearer what? Nearer A compared to B. But when you look at the other case, which is this case here, you realize that it is 4, which is first. So that is 4 to 1. So let us first of all, don't mind about the negative, but look at the magnitude of the values. This is 4, this is 1. So you are looking at AP to PB. So when A to P is taking 4, it means P should be the other side of A. P should be the other side of A. So this is what basically I'm talking about. If we were given, for example, AP, and this is P to B, and it is 4 to 1, 4 to negative 1, so you are having this, you are having A to P, A to P, P to B, P to B. This is equal to, you are having 4 to negative 1, 4 to negative 1. So this 4 implies that 4 corresponds to AP, this one corresponds to that. So for that case, when you are allocating your P, you have A and B. Then you should know to which side should P be. If P is this side here, if P is this side here, then this side here becomes smaller compared to the other side. Is that one okay? So P cannot be nearer A this side because A to P is bigger than P to B. So for that case, if you are rotating that, then P should be located on the side of what? On the side of B, such that A to P is taking 4 parts and this one here is taking only one part. But when you are looking at, for example, A to P, P to B, and this is like -1 to 4. I'm giving you two scenarios where we shall be looking at how we allocate P. So when I'm locating that, if I have A to B, then I realize that P to B is bigger because P to B is taking what? Is taking 4. And A to P is only taking only 1. So when you are allocating that, it means P to B is bigger and P should be this side of A. So such that the whole of this takes 4 parts and this one here takes only one part. So the allocation of P, or this point here that divides AB externally, you should be careful on how these values are arranged, such that you know where exactly do I need to put the P. That is the most important thing. Now, let us look at one more example. We did this example here, which was about internal. So this one, the point P was dividing AB internally, so we did part A. Now we have to look at part B. So part B is 4, -1. Put for me down these ones here, A and B, such that we refer to them. So for part B, it is 4 to -1. So 4 to -1, that is our part B. So part B, that is 4 to -1. So 4 to -1, that will be same as, we are having point P dividing AB. Now this is externally. So for 4 to -1, here P divides, here P divides the line, here P divides the line externally. The reason why we are saying that is because of that minus. So you're having 4 to -1. So it implies point P divides your line AB externally. Now, we are having point A as this, point B as that. So let us put those points there. So our point A is 3, 2.
3, 2.
Then point B is
-1, 4.
-1, 4. Now here we are saying when you are given 4, -1, it means that P divides the line externally. And if P divides the line externally, let us first have our line. So our line is A to B. Our line is A to B. But we are told P is dividing this line externally, meaning that we can allocate P this side or allocate P this side. Now it will depend on what we are having here. You realize this is P dividing this AB. So which means we shall have A to P, then P to what? P to B. Now this should be in this format, A to P, P to B. So if A to P is taking 4 and this is taking 1, so where should P be? Should B to be this side or the other side?
This side.
Should it be the side of A or the side of B?
Side of B.
The side of B. So this is where we should have P. Such that A to P, there are how many parts? There are 4 parts, isn't it? Then B to P, there are how many parts?
-1.
That is -1. So, but it is only 1 part. So don't look at the negative value. The negative value is implying that this P is outside, is cutting this line AB from outside, okay? So don't, when you are rotating, there is no need of the negative. The negative implies that your P is outside the line AB. So this P, we don't know it, so that is XY. This one here is -1, 4. This one here is 3 and 2. So here you have very many ways of how you can do this. First of all, the form that you already know that A to P, P to B is 4 to -1. But someone can also deal with this one here in a different way. For example, if I know from A to P there are 4 parts. From A to P there are 4 parts. Then from B to P it is only 1 part. So how many parts are here?
3.
There are
3.
There are 3. There are 3 parts to make the total, which is 4. Which means that someone can use this. Another person can also use another one where he uses, for example, A to B. can use A to B, B to P with the ratio which will be
3 to 1. Negative 1.
3.
3 to negative 1.
No, don't include the negative now. Look at the directions. A to B,
Okay.
B to P.
Oh, okay.
A to B, there are 3. B to P, it is 1. So the negative comes out when you are considering different directions. Here I'm considering A to P, but P to what? P to B. You realize that the directions here are different, but here the directions are not different, isn't it?
Yeah.
So here the directions are the same, but when you look at here, the directions of AP and PB are different. So one of these must be a negative. So this is one ratio that someone can use. What else can someone use? Can we extract another one? You can choose any so long as they are having ratios. What about if you choose A to P and B to P? Is it okay? A to P.
Oh, okay. A to P and
A to P. B to
B
P.
to P.
What will that one be equaling to?
4 and 1.
Eh?
4 and 1.
4 and 1. That is 4 to 1. Now here you don't include the minus because your directions are what? Are the same. Okay? So you can use this, you can use this, you can even use this. So the most important thing is you must know how to locate this one on your diagram. Know where P is supposed to be. If the first value is bigger, then it means P should be the other side of the value. So if I have P dividing this A, B, so I must have it in the form of A to P, then P to B. So you must know which one is bigger and which side should I put the P. Then from when you locate it here, then the next thing, you can pick any of these. We can even try. We shall try any of the two and we see if we are getting the same answer. Now, let us even begin with this. Let us consider A to P, then P to B, which should give us 4 to negative 1. Here you don't need to forget the negative 1 because of the directions here. The directions are different. The negative can be on a 4 or can be on 1. It does not matter. The most important thing is that we are considering different directions, and so you must include the negative to show that the directions are different. Now, from this, what is AP? A to P is OP minus OA. Oh, before that, we can first put it in fraction format to make life easier. So this is AP divided by PB, which is equal to 4 divided by negative
1.
Negative 1. So you can cross multiply. Have negative AP is equal to 4 PB. So when you look at this now, you can get this one out. This is OP minus OA, which is equal to 4 into PB. That is OB minus OP. I hope that one is okay.
Yes.
Now from this given point, you can put the negative inside such that it becomes OA minus OP, which is equal to 4 OB, then minus 4 OP. Then when you look at this, now we can try to have we can collect like terms such that we take this one or we bring this one this side. Let us bring this one this side and take this one the other side. So we shall have 4 OP minus OP, which is equal to 4 OB minus OA. So having this is 3 OP, which is equal to 4 OB minus OA. So we have OB and OA, so we substitute. So this is 4 into what was our OB? We had our OB as negative 1, 4. So can we substitute it there? Negative 1 and 4. We had our OA as
3, 2.
3, 2. So we shall put 3, 2 there. So 3 OP will be equal to, we first multiply this one. This is negative 4. This is 16. This is minus 3 and 2. And when we simplify that, we shall have 3 OP, which is equal to this, and this will give us negative
7.
Negative 7. 16 minus 12 will give us 16 minus 2.
14.
So let us divide it through. We shall have OP as a third into -7 and 14, which will be same as multiply this on each of these. Don't multiply one with this and this with that. That will be wrong. This is a scalar which must multiply in each of these. So this will be -7 over 3. This and this, that is 14 over 3. So meaning that our point P will be same as -7 and 3, then 14 and 3. So we must conclude using the format that we are given. Remember, it is given in coordinate form, so we must conclude in that format. Okay. Now from there, I want us also to look at if someone does not consider the one of a negative, whether it will give us the same thing. Now you can choose any of these. If someone chooses A to B, then B to P, you are considering purely negative, positive direction. Then A to P, B to P still is a positive direction. So there, as we said, the moment you are able to put it here, this one simply shows the direction. The negative one simply shows the direction. But when you are putting here, when you are putting it here, don't include the negative there, because here you are considering the sections. So this is taking the whole of A to P is taking 4, but P to B is taking 1. So which means the remaining one is 3. So let us consider this format also. We see what we shall get. Let us take this one now. Let us consider A to B, then B to P, which is 3 to 1. So A to B, that is AB divided by PB, which is 3 divided by 1. So we can cross multiply. So 3BP will be equal to AB. So when we look at that, we can now simplify as well. This is 3 into OP minus OB, which is equal to OB minus OA. So this will give us 3 OP minus 3 OB, which is equal to OB minus OA. So this will give us 3 OP, which is equal to, when you take this one the other side, it becomes a plus. So it becomes 4 OB minus OA, isn't it? So when you look at this, can you realize that what you have here is exactly what you had here?
Yes.
So it means you will get the same thing, because this and this are the same. So you will also get the same answer. So from here, you substitute like that, and you will get the same answer. Similarly, for a person who uses this A to P, then B to P is 4 to 1. A to P from here to here, B to P. So there we are still neglecting the minus here, because all these ones are in the same direction. So when you look at that, A to P, then P, is it B to P? This is 4 to 1. So there you are not including the negative. The negative only comes in when you are having different directions. So when you consider this A to P, then B to P, you are also taking 4 to 1. So still you should be able to get the same answer. So we can also try to manipulate this A to P, B to P is the same as 4 divided by 1. So this is A to P, which is equal to 4 B to P. So try to manipulate. So I have 4 B to P is equal to A to P. So try to simplify that. B to P, that is 4 into OP minus OB, which is equal to OP minus OA. So this is 4 OP minus 4 OB, which is equal to OP minus OA. So still you can bring this one this side, take this one the other side. So it will become 3 OP, which is equal to, take this one the other side, 4 OB minus OA, which will still also be the same as this one here. Is that one okay?
Yes.
So the most important thing here is to know how to extract out this information. If you know how to extract out this information, then you can easily know where to put the P. So the moment you put the then you can use any other vector, not necessarily the one.
Okay.
So I hope that one.
Is clear. Yes.
So let us look at that was to negative 4. So we are having one. You try to mute the So still we are having A and B. So our A is 32. So let us look at this part here. Now for this part we are having 1 to negative 4. So it means here still the point P divides the line externally still. But now we should be able to note the difference between this part C and part A and actually and part B. This part here was 4 negative 1, but here we are having 1 and negative 4. So there is a that interchange. That the other one was 4 negative 1. This is 1 negative 4. So still looking at this, still the point P will be located differently for this case as well. Now you will guide us on where to put the P. So if I have my A and B here, so where should P be? One, P can be this side or can be this side, but it will depend on the given ratio. So which side should we put the P?
Side of A.
It is the side of A. So it means it is the side of A where we should put the P. The reason is this ratio, if we put it in terms of if P is dividing this to A and B externally, then we look at A to P, then P to B. So you realize that A to P will be only 1 and P to B will be 4. So which means P to B should be bigger than A to P. So that's why it should be this side. So we can still have it as XY. So it means from here up to this given point, there are how many? There are 4 parts, isn't it?
Yeah.
Then from P to B, it is only one part. The minus is there simply because AP and P to B will be in different what? Directions. So can you give me different ratios that we can consider here? What will be the first one?
A to B.
A to B.
B to B.
Then
B to B.
B to B.
B to B.
Is this one okay? What you mentioned? A to B?
A to B. And then P to B.
P to B.
Yeah.
So what will this one be equal to now? A to B.
So, A to B will be 3.
3.
Yeah.
Then
P to B will be 4. No. A to B 3.
Also 3. How is it?
A to B.
You are the one who has selected it, so you get to the ratio.
B3.
A to B. You are saying from here to here.
Yeah.
There are 3, of course, because from here to here there are 4. This is 1. So here we have 3. Then you are saying again P to B.
No, it's supposed to be A to P.
A to P.
Yeah.
So you are saying we should have A to P.
Then A to B.
A to P, A to B, like this.
Yes.
This should be
1, -1.
A to P, -1.
Then 3.
Then 3. Let
Yes.
us check. A to P, this is the direction going that side. Then A to B is going okay. One of them must be negative. This is true. Which else?
P to B.
P to B.
Then A to B.
P to B.
A to B.
A to B.
Yes.
P to B. Yes. What will be the ratio?
P to B is 4.
4.
No. This A to B, the second one. P to B, A to B.
P to B.
P to B.
This one should be?
This one should be A to B.
A to B, which is there?
A to P. P.
Okay, to P.
Yeah.
So we put the P here.
Yes.
So you are saying P to B, A to
And,
P. So what will that one be?
-1.
4 to -1.
Yes.
Do we have another one? You also have the one that was actually given, A to P. P to B. A to P, 1. P to B, 4. But one of them must be a negative. So you can put a negative there or a negative here. Do we have the one without a negative? The one without a negative, can't we consider P to A and A to B?
Yeah.
P to A, then A to B.
So this the arrangement of it.
Yes.
Arrangement of the letters does not matter.
It does not matter. What you only need to know is what is their corresponding ratio, and also is there like difference in the directions. For example, you can say P to A, then A to B. But now when you look at that, it means you should have positive here because they are in the same what? In the same direction. So the arrangement does not matter so long as you take into consideration the direction.
Okay.
Yes. So you can have P to A, then A to B. Okay. Which will give us 1. P to A is 1. A to B, they are 3. So you can have this.
Yes.
You can have this. You can have this. There are very many that you form. So long as you know actually how to arrange it, you can form as many as possible. And the moment there is a difference in the direction, please put a negative. The negative can be on this or can be on this. The negative can be on this or on this. So it does not matter where you place it.
Okay.
Do we have another one? You can even have P to B, then A to B. P to B. So P to B. P to B, then A to B. So that one will be P to B, they are 4. A to B, they are how many? They are 3. So you can see you can have as many expressions as possible. The most important thing is to know which one takes which. If it is AP, AP should take 1. AB is taking 3. So long as you know these allocations here, you can form as many as possible. So let's choose one and we use that to get to the solution. Is the total supposed to be 4 or it can be any? No, the total must be 4 because from here to here is the largest, so it should be 4.
What of this last example you gave?
This one?
Yeah.
No, it does not necessarily mean that when you add these ones, it must be. For this one here, P to B and A to B, we are considering their corresponding divisions. So this has 4, this has 3. So these ones will give you, it does not necessarily mean that the total ratio here that you get must be what? Must be a 4. Okay. Yes. Because even here when you look at this, now will you say it is 4 minus 1? That one will not work. So what works is that P to B, what is the corresponding value or the corresponding value of P to B, which is 4. Then A to B is 3. So what is the corresponding value? That is the most important thing. Okay. But if I say P to B and I give it a 1, that one will become wrong. Because P to B is taking how many? They are 4. A to B, they are 3. So these must be the corresponding values of each of these that we will pick here. Okay. So we can choose any and we use that.
Okay.
Which one can we use?
The last one.
We use the last one.
Yeah.
So if I use P to B, A to B, that will be 4 to what? 4 to 3.
Yeah.
So this will save as P to B divided by A to B, which is 4 divided by 3. Cross multiply. When we cross multiply, 3 PB is the same as 4 AB.
AB.
So this is 3 into OB
OB minus
minus
OP.
OP, which is equal to 4 into OB
OB
minus
OA.
minus OA, which will be same as having 3 OB minus 3 OP, which is equal to 4 OB minus 4 OA. So let us take this. We can even maintain it. Negative 3 OP is equal to, we bring this one to the other side. 4 OB minus 3 OB, we get OB minus 4 OA. So let me divide it through by this negative, such that I get 3 OP, which is equal to negative OB plus 4 OA. So this is 3 OP, which is equal to 4 OA minus OB. Now let us substitute. We had our OA as, was it 3, 2?
Yes, 3, 2.
Was 3, 2.
Yeah.
Minus OB.
Negative 1, 4.
Negative 1, 4. So this will give us
12. 8.
Minus negative 1, 4. So this is 3 OP. So 3 OP will be equal to 13 and 4. So divide through by 3. So your P should be 13 over 3 and is that one okay?
Yes.
So you need us to first divide by 3, then we put it inside. So this will be a third times 13, then a third times 4. So we shall get that. Can we also try one and see if we are getting the same expression as we did here?
Okay.
We can try one value to confirm that. So we can try which one?
We try PB and AP.
We try
PB to AP.
PB to AP is 4 to negative 1, eh?
Yes.
Okay. So let us have this as PB AP, which is 4 over negative 1. Cross multiply, negative PB is equal to 4 AP. This will be negative E2 OB minus OP, which is 4 into OP minus OA. So this will be same as OP minus OB. When I put the minus inside, this is 4 OP minus 4 OA. Can we take this one this side and bring this one this side? So 4 OA minus OB will be equal to, when I take this one the other side, to become 3 OP. So clearly you can see 3 OP is equal to 4 OA minus OB, which is same as this.
Yes.
So each of these that you select, so long as here you have clearly put it where the 4 is supposed to be, you have put it there, then you get this one here, then you get that. You can choose any of the expressions to use, and they will all give you the same answer.
Okay.
So what is important is to know where P is. So if you know where P is it the side of A, is it the side of B? Because when it is given, if you are given A and B, and you are told P divides this one externally, then P must be either one side of the side of P, or the side of A, or the side of B. But the side to choose now depends on the ratio which is given. If they give you 1 to negative 4, then it means this stands for AP, then the next one stands for PB. So which means that here, if you are locating P, P should be closer to what? Closer to A. If it is given as 4, maybe to -1, then the 4 is the bigger value compared to this. So it means this stands for AP, then P to B. Then it means the value of the P should be the other side of what? The other side of P. So that is how we locate it. So our question 1 will be answered. So far, we shall have that one answered. So this part is done, this part is done, and this part is done. So we shall be able to do that. The next question says 2 points A and B are such that A is that and B is that. A point P divides line AB in the ratio of 2 to 3. Find the position vector of P if it divides AB internally and externally. Will be the one to guide us in that one now. So put the points A and B and the ratio that is given. Okay, so A is that, A is 0, 1, 4, B is 2, 6, and 0. Is that done?
Okay. Yes.
Now, let us start with part 1. If P divides the line internally, what will happen? I will draw my line here. I have my A, which was 0, 1, 4, and B, which was 2, 6, 0.
Yes.
They are saying the ratio is the same, 2 to 3, but P is dividing this line AB in this ratio of 2 to 3. So where should P be? So you just tell me what to do. I will be following your say.
You put P closer to A.
I put it here, this side.
No, internally, close
internally.
to A.
Okay. So let me have my P there. Yes. What should be the coordinate for P? In which format?
IJK.
In the format of IJK, but those are, so when we are putting here in terms of coordinates, what should it be? Because those are unit vectors. The other one was in terms of X and Y. So this one should be? X, Y, and
Z.
X, Y, and Z. Okay.
Okay.
We move. What should happen? Where should the 2 and 3 be?
2 should be on. It is the AB.
This 2 stands for what? AP, BA, because you must know it from here, even before I put it here. 2 stands for?
2 stands for AP.
AP. Then this stands for?
For AB.
AB. P divides this internally, so from A to P, you must move from P to what?
P to B.
P to B. That is the order. From A to B, if they say P divides this internally or externally, whichever value you are given, it should be of the order A to P, P to what?
B.
P to B. That should be the order that you should follow. So which means we should have
2 divisions.
2 here, then here
3.
That is what you should have. So long as you know these ones here now, you can get any expression of your choice. Which one should we use now?
She'll use AB.
AB
and AP.
AB to AP.
Yeah.
Like this.
Yes.
So this should be?
Should be 5.
A to B should be 5.
5, 2.
5 and 2. A to B 5, yes. Then A to P 2. That is okay. So there are very many someone can use. Someone can also take A to P, the way it is actually given. Then P to B, which is 2 to what?
2 to 3.
which is 2 to 3. That one can also work. Then in case you are to change the directions, then you must record that you have to put the negative there. Now we can use that. So this is same as AB divided by AP, which is 5 divided by A. You are the one to do.
5 divided by 2.
5 divided by 2.
Yeah. Cross multiply, it will be
cross multiply
2AB
2AB
is equals to 5AP.
5AP.
Yeah, you find the position vectors to be 2 into 2 OB minus
OB
OA
minus OA.
OA
equals to
5 into OP minus OA.
Minus OA.
Yeah. Simplify 2OB 2OB minus 2OA
minus 2OA
equals to 5OP minus 5OA.
5OP minus 5OA.
Yes. You bring the negative 5OA to the left hand side.
Okay. So it becomes
5OP equals to
5OP equals to 2OB
plus 4OA
plus
2OA. 3 yeah, OA.
OA.
Yeah.
Okay.
Then we substitute.
We put OB. What was OB?
OB is 260.
260 plus
OA 014.
014.
Yes.
So this will
412 0.
412 and 0
plus 0 3 and 12.
0 3 and 12.
When you add that, it will be 4 15 and 12.
Okay.
Divide by 5. By 5, it will be 5 into
5. When we divide by 5, it remains 5 this side?
No. Divide here, it will be 1 over 5.
1 over 5.
Yeah, into 4 15 12.
Okay. Which will be?
OP equals to 1 over 20.
OP is equal to?
4 over 5.
4 over 5.
15 over 5.
15 over 5.
12 over 5.
12 over 5.
Simplify the 15 over 5. OP equals to
so
4
P,
over 5.
P will generally be?
4 over 5.
4 over 5.
1, no. 3.
3.
12 over 5.
12 over 5. And that will be the answer.
Okay.
So that is what was required there. You can use any other. You can use AP to PBs 2 to 3. You can also use actually AP to AB. Is it possible? AP to AB, yes, is equal to 2 to 5.
Yes.
Actually, it is the reverse of this. It is the reverse of that, which is actually almost similar when you take the reciprocals. So you will get the same answer by using even these ones here. So long as you know how to locate this, then you can easily get it in different ways. That was for internally. Remember, it also divides it externally. So what should it be? If P divides AB externally. It does in that one as well. What should we do?
You draw a line AB.
We draw the line AB. Draw the line AB.
Since P divides AB externally, it should be
the ratio was given as 2 to 3.
Yeah, 2 to 3. So if P divides the line AB externally, it should be on the side of A.
Should be the side of A.
Yeah.
So I should put here P.
Yeah.
So when I put P here, so what will be from here to here? What will be from here to there? What will be from here to here?
AB will be 2.
A to P will be 2.
No. A to B.
A to B will be 2.
Yeah.
So here will be 2.
Yeah.
Then here
from B to P will be 3.
From B to
P.
Like this.
B to B. Yes.
Should be 3.
Yeah.
Then this one.
Which one?
A to P.
That one will be 1.
Sure. Read again. P is dividing AB externally in this. Meaning if it is dividing this externally, of course, one of them must be negative by definition. I'm not yet confident with this expression of yours. Something is not correct somewhere. Think about it. Where exactly are you supposed to have the 2? Are you supposed to have the 3?
The 2 is supposed to be for the larger value from P to B.
Now, first tell me, how do you read this? This one is corresponding to which value? This is corresponding to which value? That is what I told you at the beginning. If you are given 2 to 3, and they are telling you P divides AB in this, what does this first value represent? What does the second value represent?
The first value represents external division.
Okay, in terms, I need it in terms of AP and PB.
Yeah. AP. AP. PB. AP is the external division. From A to P is
before even coming to external and internal divisions, those ones come later. But when you are given a ratio, you must interpret it first, even before coming to this diagram. As I said the first value, if they say this divides this line in this format, so whether it is internally or externally, the form remains the same. This corresponds to A to P, then this corresponds to P to what?
B.
Because you are having the line A, B, irrespective of whether it is external or not, this ratio represents A to P, then P to what? P to B. Okay?
Yeah.
So P is the common value. It is A to P, the first one, A to P, then P to what?
B.
P to B. So the first value represents A to P. The second value represents P to what?
B.
P to B. Now, after knowing that, that's why, like here, you said, because if I'm given 2 to 3, the first value goes for A to P. The next value goes for P to what?
B.
P to B. That is how we interpret the ratios. Okay? Yes. When you are given this, they tell you P divides AB in the ratio of 1 to -4. Even before you do the interpretation, the first value represents A to P, the next value represents P to B. Okay?
Yes.
The same thing happens here. When you are given this 4 to -1, you are told the first value represents A to P, the next value P to B. That is how it is interpreted. Now, after knowing that which one corresponds to which, then it becomes clear when you are putting it on the diagram. But this shouldn't be confusing you, because now what you are giving me here is you are saying 2 corresponds to A to B. Is that one right?
No.
That one becomes wrong. How can you say P corresponds to, and yet they are telling you P divides this line in the ratio of 2 to 3. So here you are not having A to B anywhere, but you look for A to B after you have got A to P and P to B. So whenever you are given a ratio, first interpret it in that format, then it becomes clear. Now, you tell me where should I put which one?
So A to P should be from the external division.
So here you are interpreting it that A to P is taking only 2 parts. P to B is taking 3 parts, isn't it? Yeah. Which means that the P must be the other side of what? Of A. Yeah. For this one is okay now. The representation is okay, but now the values are not yet okay. But of course, if you know that P is this side now, A to P, you know it is taking how many? 2. 2. It is taking 2. So the 2 should be where? There. Should be there. Then P to B is taking how many? 3. 3. From here to here, there are 3. So it means from here to here, how many? 1. Is only 1. Whether it is big, this one now, you might say this is bigger. But this is just a sketch. So 2 is there, 1 is there. Is that one okay? Okay. So the moment you are given the ratios, first put it in that format of, if they say P divides this one, whether internally or externally, first put it in that format. Then when you put it in the format, you will know where exactly P should be. But of course, P cannot be here, and you say P to B is this side, and I put it 3 here, then P to A, then you put, because now that one will be not a correct sketch. If you say like this, if I have A to B, then I put P this side, it implies that B to P is taking 3 parts, and from here up to here, how many are they? They are 2. Can that one be right? No, you cannot have 3 divisions here, and from here to here, they become how many? 2 divisions, isn't it? Yeah. So that's why the P must be that such that this becomes 3, and this one now becomes 2. That is real. That one is real. And this one takes 1. That one is possible. But you cannot have P this side, and now you find B to P is smaller than A to P, and yet the 3 is now contained in the 2. That one cannot be possible. So that is why we allocate the P the other side. Okay. So that would be actually the last example. So you must know how to treat some of these things here, because that is the part which usually confuses students. But it's very easy, especially when you know how to locate it. It becomes very easy because there is no much restriction there. You know, from this, I put this. The moment you already allocate it, then you can put it in your own language. Allocate it. The location is the most important thing, because after the allocation, you can use any ratio, so long as you know the directions very well. So let me hope that that one is very okay, because after allocating it here, then it becomes easier for you, I hope. Yes. With the examples we have seen, now you should be able to manipulate that and get the value. I hope my assumption is okay. Shouldn't assume. I might assume that it is okay when it is not okay.
It's okay, it's okay.
Okay, from there, I believe you should be able to move. Now, I want you to... The only part is how to locate the 2, the 3, those ones there. That should be the most important thing. This was a 3. This is the 1. So let me get for you one example to interpret for me, because the interpretation is the most important thing there. The moment you know how to interpret, then it becomes easier. So let me get one example for you to interpret. This is for internally. Internally, you are very okay. Okay, let us be moving. I will get for you some, which I will give you as trial questions. So with that one will be done. So I hope you will be able to finish this one out and get the coordinates for P. So next I want us to look at the next part, which is about the scalar product or dot product. Ike, I hope you are there.
I have put mine on mute.
Okay.
Yes.
All right. So let us go to the scalar product, or what we call the dot product of two vectors majorly. So this dot product is majorly for two vectors. So when you are looking at the scalar or dot product of two vectors, it is majorly defined in terms of the magnitudes of the two vectors involved and the cosine of the angle between them. So if theta is, for example, the angle between the vectors P and Q, then we define the dot product to be P dot Q is same as magnitude of P times magnitude of Q cos of the angle. So the angle should be between 0 degrees and 180 degrees. Now, from this definition, we can get a few things. One, if, for example, the angle between two vectors P and Q, if the angle between two vectors P and Q is, for example, 0 degrees. If it is 0 degrees, then what will happen? It means P, vector P dot vector Q is the same as magnitude of P times magnitude of Q cos of 0. And cos of 0 is 1. So it means that P dot Q will be same as the magnitude of P times the magnitude of Q. This will be true. That is, if the angle between the two vectors is 0. So if the angle between the vectors is 90 degrees, what happens? It means we shall have vector P dot vector Q, which is same as magnitude of P times magnitude of Q cos of 90 degrees. And the cos of 90 degrees is 0, giving us P dot Q is equal to 0. So in other words, when you are looking at the dot product, you are majorly looking at obtaining, especially they usually ask this if you need to obtain the angle between any two vectors. So the angle between any two vectors can easily be obtained using the dot product. So and the dot product works for two vectors. So if you are getting the dot product of two vectors, you simply get P dot Q, which is equal to the magnitude, which you know how to get now, magnitude of that, then times the cosine of the angle. And we have seen that in case the two vectors are perpendicular, or the angle between them is 90 degrees, then it means when you dot those vectors, you will get a 0. So if the angle between two vectors is 90 degrees, then the dot product of those two vectors will be 0. Very important. Now, if a vector is dotted with itself, what happens? If you dot a vector with itself, for example, you are dotting P together with P, it means you are having magnitude of P times magnitude of P vector cos of the angle. If you are having two vectors dotted with one another, then it means the angle between them is what? Is 0 degrees. So if the angle between them is 0 degrees, then it means P dot P will be same as magnitude of P times magnitude of vector P, which is actually same as magnitude of P, which is squared. So that is what happens when you dot a vector by itself. So it is important to look at some of the properties of the scalar product because they are the ones that will be guiding us on what to do. The first one is when you are dotting these unit vectors, you are getting I dot I, which is same as J dot J, which is same as K dot K. Then we are saying the value is 1. But of course, we must know where this one comes from because if you remember very well, I is same as 1 and 1 and 0, isn't it? So if I'm having I dot I, then it means I'm looking at magnitude of I, which is squared. If you recall what we did here, we said that when you dot a vector with another vector, it is same as the dot product is same as having the magnitude of that vector, which is squared. So the same applies to this. If I say I is 1 0, then that is in 2 dimensions, and then it means I dot I is same as magnitude of I using the same principle here, because the angle between them is 0. So it means this is same as magnitude of I, which is same as, but magnitude of a number is same as getting 1 squared plus 0 squared. But the whole of this is again squared. So this is same as having the square root of 1, which is squared, and this still gives you 1. So that's why we are saying I dot I is actually same as J dot J, which is same as K dot K, which is same as I. But when you dot I and J, or I and K, or J with that, then the angle, this value gives you 0. Why we are saying it is a 0 is because we said that if you are having 2 vectors which are perpendicular, P dot Q will give you what? Will give you a 0. Because I and J are perpendicular to one another. If you recall how we locate that, if I have my J here, I have my I here, you realize that the angle between them is 90 degrees. So when I dot I with J, then by definition, this should be magnitude of I times magnitude of J times cos of the angle between them. But the angle between them is what? The angle between them is 90 degrees. So giving us this one as 0. So it means I dot J will give us a what? Will give us a 0. The same applies to I and K, and then J and K. So that will also give us a 0. This one we have talked about it. P vector P dot vector P is same as magnitude of P itself. So that is what happens there. Then for distributive law, it is possible if you have P and you are dotting it with Q plus R. These are vectors. You can have it as P dot Q plus P dot R. So this is true. If K is a scalar and you are getting P dot K times a vector Q, then this is same as having K. You can first have this vector P multiply dotted with vector Q. You can still have that. Then you can as well have the K multiplied with P, then after you dot it with Q. So it is still also possible. So where K is a scalar. So these are some of the properties that we shall use. But the most important ones when you are looking at these two, because they are the ones which will be defining on how a scalar product is supposed to be done. So it means whenever we are dotting, we majorly look at I components together with I components, J components together with J components, K components together, because the moment you dot the I component with the J component, you will go to 0. So when we are dotting, then we look at the I component from one vector, dot it or multiply it with the I dot component from the other vector. And from there, it will be possible. We can understand that by looking at this question here, which says, given that vector P is this, vector Q is that. So we need to get P dot Q. So to do that, we shall say that since we are given vector P as I minus 2K, and we are having Q, which is also same as, this is vector Q, which is also same as 3I minus 3J plus K. Then we need P dot Q. So what will be P dot Q? So when you are dotting P with Q, you can say that this is same as P. Our P is I minus 2K into Q is 3I minus 3J plus K. Now, when you are dotting, from the properties that we have seen, when you dot I with J, it goes to 0. Then I with I, the value become I dot I becomes 1. Now this implies that if I'm dotting I with the 3I. So I'm having I dot 3I. If I dot I with this, there is a dot here. So let's have the dot there. If I dot I with the J, it goes to where? It goes to 0. Okay? So it means if I dot this with this, it goes to 0. This with this, it also goes to 0. So it means I need to have this one dotting this. Then for the J, what is the J component here? The J component is 0. So it means, again, you are adding there a 0J, which you are dotting with negative 3J. And you are adding there this 2K, because if I multiply this one with this, it will be 0. This with this will be 0. This with this. Now by properties, that will be possible. So I have negative 2K dotting it with K. As we have said, J with J is 1, so I get 3. I get 3. J dot J is 1. 1 times 3 is 3. So this will give us 0, because 0 times this will be 0. J times that is 1. So when you have negative 2K dot K, the K dot K is 1. So I get negative 2 times 1. So this will be same as minus 2 times 1. And this will be same as 3 minus 2. So which will give us a 1. So when you are dotting, it is important, one, to dot the corresponding coefficients of the unit vectors. Now, instead of doing all that process, someone can simply dot in this way. So P dot Q, that is vector P, that is the same as, now you can have your P. What is your P? Your P is 1, 0, negative 2. Then you are dotting this with 3, negative 3, and 1. So if you are dealing with this, you can do it at once. Get 1 multiplied with 3, get 3 plus 0 times negative 3, 0 plus negative 2 times 1, negative 2. And this will give you 1. Because the most important thing is that you are dealing with the corresponding, you multiply the corresponding components. 1 with the 3, 0 with this with this. Simply because when you dot I with I, it is possible you get a 1, but I with a J, I with a K is a 0. So that's why we can easily do this. You get 1 with a 3, 0 with this one with this. You can do that one and get that value. Now, why we are not using this expression for the formula is because we don't know the angle. If I need P dot Q and I don't know the angle between the two vectors, then I cannot easily use this. So I can easily use this if I know the angle. But even if I don't know the angle and I know P and Q, I can easily dot them using the principles for the dot product, the properties of dot product. So that is how we do the dot product. The next part is that we need the angle between P and vector Q. So let us see how to get the angle between the two. So from vector P dot vector Q, which is equal to magnitude of P times magnitude of vector Q, cos of theta, we can be in position to get the angle. What we need is to get P dot Q, but we have already got P dot Q. So vector P dot vector Q is 1. So what we need to come up with is magnitude of P and magnitude of Q. So our P is 1, 0, negative 2. So that will be magnitude of vector P. That is the square root. I hope you still recall that. So we are having our P here, vector P. We can put it maybe for reference, I minus 2K. We are having our Q as 3I minus 3J plus K. So what will be magnitude of P? 1 squared plus 0 squared, the component of J, plus negative 2 squared, the component of K. And this will be same as the square root of 5. Likewise, we get magnitude of Q, vector Q. So which will be 3 squared plus negative 3 squared plus 1 squared. And this will give us the square root of 9 plus 1. That is 19. Now, from this given expression, from this, we should be in position to get the value of theta. So our P dot Q is 1. This is magnitude of P, which is square root of 5. Magnitude of Q, which is 19. Then cos of theta. So 1 will be equal to, so we can multiply this, 19 times 5, cos of theta. So 1 should be equal to square root of, get 19 times 5, 95, then cos of theta. So get your cos of theta there. So cos theta will be equal to 1 divided by the square root of 95. So theta is cos inverse of 1 over square root of 95. So get the value of theta. So is that process very okay? Yes, Mike, is the process very okay?
Yeah, it's okay. It's okay.
Okay. So that is how we obtain the angle between two vectors. The most important thing is to know how to dot. But dotting is very easy. Simply have it in the column form. This one is disturbing. Have it in this form. Simply multiply the corresponding components, one with the 3, this with that, while you're adding. You should be able to get that angle. We can look at the next question. Next question shows that the following pairs of vectors are perpendicular. What do we need to show there? What do you think we need to show?
We need to show that the angle between them is 90.
We need to show that the angle between them is 90. So if we happen to get the angle between them as 90, then we conclude that they are perpendicular, isn't it?
Yeah.
So let us look at that. However, there is also one other way you can also do that. Other than doing that, we know that if the angle between two vectors is 90 degrees, then when you dot the vectors, you get what? You get 0, isn't it?
Yes.
So you can also deal with the dot product. Then if you are able to dot A with a B and it gives you 0, then you conclude. Or else you can also show that by getting the angle as 90 degrees. But without following all that process, you can simply dot. If the dot product is 0, then you give the conclusion that they are perpendicular.
Okay.
So we can do one, you will try another. So for perpendicular vectors, we can show that when I get A dot B, I get a what? I get a 0. So you can try that simple one, A dot B, vector A dot vector B. So that is 2, 6, and 4. You are dotting this one with negative 2, and 4.
Oh.
So this will be same as negative 4 plus negative 12. This times this, plus this times this, plus this times that. So which will give us? Is it 0?
Yes.
So A dot B is equal to 0. Now since vector A dot vector B is equal to 0, and then the vectors A and B are perpendicular. That is one way of how you can do that. Or else, you can consider or show that the angle between vectors A and B is 90 degrees. So you can do that. And you can do that from vector A dot vector B is equal to magnitude of vector A, magnitude of vector B, cos of theta. So of course, you can see that this is already 0, so 0 is equal to magnitude of A, magnitude of B, cos of theta. So divide through by this. So it means that cos of theta, 0 divided by any number is 0. So your theta is cos inverse of 0, which is 90 degrees. So you can also do that. If you want, you can go on and get magnitude of A, magnitude of B, you substitute. So, but this can be enough. Simply look at the dot product. If it is 0, then you can conclude from there.
Okay.
Okay, so we can look at the next part. So that one you should be able to take us through that. Find the value or values of the scalar lambda such that the vectors R1 and R2 are perpendicular. So what should we do there? So we are told that R1 and R2 are what? Are perpendicular. So since a vector R1 and vector R2 are perpendicular, then what does it imply?
Dot product is 0.
The dot product is 0. And if the dot product is 0, then this implies that we shall have R1, which is 2, 3, and 5. We dot it with 4, lambda, and negative 7. We equate this one to what?
0.
We equate this to 0. So what will this one give us? 8 plus 3 lambda minus what? Minus 35, eh? 5 times this. We are multiplying 2 times 4 plus 3 times lambda plus 5 times negative 7.
Okay.
So we are getting 8 minus 25. So 3 lambda minus 27 is equal to 0. So 3 lambda will be equal to 27. And lambda becomes 9. So that's the scalar lambda will be equal to 9. If R1, vector R1 and vector R2 are perpendicular. So that is about, I hope you are able to get this.
Yes.
Find the angle between the vectors A and B. Vectors A and B are given, so simply get that from the dot product. So where vector A dot vector B is equal to magnitude vector A, magnitude of vector B, cos of theta. So you should be able to, you know how to get magnitude of A, magnitude of B, you know how to get that. Then dot the 2. So use our normal dotting, 4 times 2 plus 3 times 5 plus that. So that one we should be able to do it.
Okay.
So we should be able to try that. There is one more question there. If the angle between the vectors A and vector B is 45 degrees, find the two possible values of x. Are you able to get that?
Yeah.
So we are that one still use dot product.
Yes.
So that is A dot B is equal to magnitude of A, magnitude of vector B, cos of theta. But your theta is 45. So you are having your x and 2. You are having 3 and 1. is equal to, get the magnitude. The magnitude will be square root of x squared plus c. Is it? The magnitude of a.
Yeah.
Then you are multiplying by the square root of 3 squared plus 1 squared. Cos of
45.
45. So this will give us 3x plus, you are dotting 3x plus
2.
plus 2 is equal to x squared plus 4 times
10.
10. Square root of that is same as root 2 over 2 or 1 over root 2. What should be done next? Can we remove these square roots?
Yeah.
If I'm to remove the square root, what do I do?
Square both sides.
Square both sides. So square here and square also this side.
Yes.
So you'll get this as 3x plus 2 squared, which is equal to, the square will cancel with this to give us x squared plus 4. It will also cancel with that. It will also square this, because everything here is squared and you are multiplying, okay?
Yes.
So since you are multiplying, each of these can be affected individually. So the square will have, be here, will also be on this, will also be on this. Then this is 2 over
4.
2 over 4. Now you can simplify it. So by 2 is 1, by 2 is 2, by 2 is 1, by 2 is 5. So expand this, 9x squared plus 2 times 3x times 2, 12 plus 4 will be equal to 5x squared plus 20. So go and simplify, go do that, simplify, and get the values of x.
Okay.
So that you should be able to try it. Okay, so we need to talk about the dot, the cross product. Need to talk about that. Before we leave this, I want you to try for me this question here. Let me put it here. So it says find the value or the values of the scalar A if the vectors and before leaving that, it is also important to note a few things. Before we leave that for the other part, it is important to note that if you have vectors A and B, actually let us consider three of them. So if you have 3 vectors, for example, A, B, and vector C, if you consider these vectors, then we must note some few things here. One, if you have vector A dot vector B equaling to 0, then it means vector A and vector B are what? Are perpendicular. They are perpendicular to each other. So A and B are perpendicular to each other and vice versa, meaning even B is perpendicular to what? Is perpendicular to A. That is 1. Now, 2, if you have A dot B equaling to magnitude of A times magnitude of B, we said that these two are equal if the angle between them is what? Is 0 degrees, isn't it? Because by definition, here we should be having a cos of theta. But if it is 0, then cos of 0 is same as is the same as 1, isn't it?
Yes.
So which means if the dot product is equal to the magnitude of the vectors, then one thing should be clear, that the angle between them is 0. And if the angle between them is 0, then the vectors A and B can be considered to be parallel. Are considered to be parallel to each other. They will be considered to be parallel to each other. That is the second note. The third note is that if A dot B is positive, then the angle between vectors A and B is an acute angle. Okay? If A dot B happens to be positive, then automatically this by all means will always be positive. Magnitude of A times magnitude of B will always be positive. So if this is positive, it means positive, you are dividing by positive value. So the angle you will get will be an angle which is called an acute angle that will be in the first quadrant. Remember, the angle between the two vectors must be between 0 and 180 degrees, meaning in the first and the second quadrant. And then it means that if you have A dot B, which is negative, if A dot B is a negative, then the angle between vector A and vector B is obtuse. It lies in the second quadrant. Another important note to put is that if you are having A dot B, this is same as also B dot A. So this is the commutative property, meaning that it holds. So if you are having A dot B, it is actually same as having B dot A. So the two are the same. So that is how we obtain, how we look at the dot product. So with those, then you'll be able to pass any number regarding dot product. So it means we shall have closed the chapter for dot product with this information. And now we can talk about what we call the cross product. So let us talk about the cross product. So when you are looking at the cross product, maybe before I talk about cross product, one more thing about this one here, about the dot product, is that the dot product is a scalar quantity. The dot product of two vectors is a scalar quantity. In other words, when you dot two vectors, maybe I put it also among the things you should note. When you dot two vectors, the value you get is not a vector, but a what? But a scalar. In other words, you don't dot two vectors and you find your angle, your answer is in terms of I, j, and k. That will be wrong. So your answer must be a scalar value. It must not be a vector quantity. Very important. So I think you should have it noted also. So the dot product of two vectors is a scalar quantity. Is a scalar quantity. And of course, we have seen that we use the dot product if we need to show that given vectors are perpendicular. So if vectors are perpendicular, you want to prove that then you simply use the dot product and you get the answer, or you prove that. Okay, so with that, let us talk about the vector product. Now that we have seen that the scalar product is actually a scalar quantity, then when you are talking about a vector or cross product of two vectors, the result will be a vector quantity. So the result will be a vector quantity. And their cross product is a vector with a vector which is perpendicular to both A and B. So in other words, if I have two vectors A and B, when I cross these two vectors A and B, and I get what we call the cross product, that is vector A cross vector B. And then this result here will be perpendicular to A, and will also be perpendicular to what? To B. What does that one mean? It means that when you have a vector product, then that product there will be perpendicular to any of the two, will be perpendicular to either of the vectors, that is either A or B. But it must be perpendicular to those vectors. Meaning that when I get A cross B, the cross product, I dot it with any of the vectors, I get a what? I should be able to get a 0. If I get the cross product, I dot it with B, then I should be able to get a what? I should be able to get a 0. But then how do we define a cross product? So still we can use almost the related expression for the dot product, but what we shall have here is that A cross B is same as magnitude of A times magnitude of B, sine of what? Sine of theta. We normally put this mu here, but in most cases, some of the expressions you might not necessarily put this, because this one here is simply a unity vector that is perpendicular to both A and B. It is showing you that this A cross B, what you get will be perpendicular to both A and B. But when you are looking at the expression, you are using it, since it is a unity vector, we normally ignore that and have A cross B, which is magnitude of A times magnitude of vector B, then sine of theta. That is the cross product. Now, a few things that you need to note is that sometimes we use this sign here. This is another way of denoting the cross, that A cross B. We might use this sign here of times, or we use this. So this is also another notation. So you can have A cross B as that, or A cross B as that. So these are the different notations we can use when we are looking at the cross product of two vectors. So this one here is simply read as A vector A cross vector B. Or this one you can read it as a vector A cross vector B. These are all vectors. Now, like the way we saw for the dot product, you can easily get A cross B, that is vector A cross vector B, also when you don't have the angle. Because if you don't have the angle, if you have the angle, you can simply substitute it like that, you get. But if you don't have the angle and you need to get A cross B, then how do you get that? You can use what we call the determinant of a 3 by 3 matrix. For example, if you are given the vectors, if you are given the vectors A, which is, for example, A1I plus A2 J, A2J plus A3K, and maybe B, which is vector B, which is B1I plus B2J plus B3K. If you have that, then how do we compute A cross B? Then we can say that their cross product is, so let us get the cross product. That is A cross B. So here we use a 3 by 3, the determinant of a 3 by 3, which is, now the first one, we shall have I, J, and K. That is what we shall always put in the first row. Then now we put the vectors A1, we put those components A2 and A3, B1, B2, and B3. So this I, J, and K should always be in the first row. Then A1, A2, these are components of vector A. B1, B2, B3, those are components of vector B. So here you use a 3 by 3, the determinant of a 3 by 3. I hope you know the determinant of that. Do you recall the determinant of a 3 by 3? Yes?
No.
Do you recall the determinant of a 3 by 3?
No.
Okay.
They didn't teach us. They did not teach us.
Okay. It is very easy still. We shall have it. So what you do, okay? You eliminate the first row, first column. Okay?
Yeah.
Then you get the determinant of the remaining entries.
Yeah.
So the determinant of the remaining entries, that is
A2,
A2, A3, B2, B3. After getting that, multiply it with this component here of I. Then in getting the determinant of a 3 by 3 matrix, this is always plus, minus. The value that you put here, it should be a minus. That is by definition. So this should be a minus by all means. It should always be a minus, irrespective of the value which is here. Okay? So
yes.
this one, now the next thing we shall do again, do the same thing. Eliminate the first row and the second what? The first time we eliminated the first row and the first column, okay?
Yes.
Now the next, eliminate the first row and the second column. So what remains will be this, 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 and this. Don't say that we eliminated this one at first. At this moment, we are only eliminating this, so we assume that these values are there. Is it okay? So it
Yes.
means after eliminating this, I'm supposed to again to remove this. Okay. Now such that we are able to see it well. So this is B1. So the next one, I assume I'm having my values which are A1, A2, A3. So when I'm to get the one to put here, I still eliminate the first row will always be eliminated. That one is the analytic one. It will always be eliminated. So eliminate this and the second one. You remain with this one, and that. Okay?
Yes.
So put them there. So this is what we shall put here. This is A1, B1, A3, B3. Now this you multiply it with what? J. Okay? Add there. So this addition is there. This minus, please don't forget that. By definition, that minus must be there in the determinant of a 3 by 3. Can you tell me what to do next? To get what to put here, which one will I eliminate?
The first row and the third column.
I will eliminate the first row and the third column. So what I remain with is what I will write. So what shall we have there? That is A1,
B1, A2, B2.
B1, then B2. Then here you multiply by what? You multiply by K. So this is what you do. I hope you still recall how to get a determinant of a 2 by 2.
Yeah.
So you get A2 times B3 minus
A3 times B2.
Yes. Into I minus, get this also, A1 B3 minus A3 B1 into J. Get this also, A1 B2 minus A2 B1 into K. So this is how you compute the cross product of a 3 by 3 matrix. So I hope the procedures are clear. So if I need A cross B, these ones must always be I, J, and K. So these ones, that is their position. Don't interchange. So these ones correspond to this. These ones correspond to the component of B. Then now to get what to put to get the one here, eliminate the first column and the first row. So get this into I. This minus, please don't forget that it is a must to be there by definition. It is a must to be there. So this is why we are saying that the cross product of two vectors is actually a vector. So whatever you will get out will be a what? Will be a vector. So there are some properties that we need to have. One is that when you cross I with J, you get K. J with K, you get I. K with this one, you get J. But unlike in a dot product, I dot I was 1, but this one here, it becomes what? It becomes 0 instead. And when you get A cross B, it is not same as B cross A. If they are telling you get A cross B, don't get B cross what? In other words, here, if you are starting, the starting value here matters a lot. A1, A2, A3, B1, B2, B3 matters a lot. So when you get A cross B, and for you instead you start with B1, B2, B3, you will get something wrong. So this is important, that A cross B is not same as B cross A. But in dot, A dot B is same as B dot what? This one is okay, but it will not work here. So the same applies A cross of vector vector B plus vector C. You can manipulate it as A cross vector B. This one is possible, distributive property. This is still okay. So here we are saying the cross product of two vectors is a vector quantity, and it is perpendicular to both vectors. Two non-zero vectors are parallel if and only if their cross product is the zero vector. You need to note that one, because in our next examples, we shall be using that. When do we say that two non-zero vectors are parallel? They are parallel only when their cross product is what? Their cross product is a zero vector. In other words, when you get the cross product of the two vectors and it is zero, then it means that those vectors are what? Those vectors are parallel to one another. That is what it implies. So this one we have talked about this. If A vector A is that, vector B is that, how do we get a vector product? Okay, we can try one example here, such that by tomorrow we can add there. So I will try one, you will try the other. Okay? So we are having vector M is that. We are given vector M is 3i minus 2j plus k. Vector N is 4i plus 3j minus 2k. Are we together there? Big man, are you still around? You are there? Okay. Now, we are having M cross N, which is same as we said. This one is I, J, and K. The first one is 3, negative 2, 1. We are putting M. Then N is 4, 3, negative 2. So we shall eliminate this, and this, get the determinant of the remaining one. So get the determinant of negative 2, 1, 3, negative 2. Then put your I there, minus. So we are taking this, and that. So the next one, we shall again eliminate this still, and now this, remain with this. So that is 3, 1, 4, negative 2. The remaining one, this, and this. Into, this one will be into J. Then plus, next, eliminate. Next, eliminate this last one with this. So if you eliminate that, what do you get? 3, negative 2, 4, and 3 into k.
Yeah.
Now get the determinant. Negative 2 times negative 2, 4, minus 3 times 1, 3, minus 3 times negative 2,
negative 6.
4 times 1, into j, plus 3 times 3, 9, minus 4 times negative 2, into k. So this will give us, yes.
4 times negative 2 is
negative 8. Negative 8, eh?
Yeah.
Okay, thank you. 4 minus 3 is 1, so we remain with I. Minus, this is minus 10, j. This and this will give us 17, k. So finally we shall have I plus 10j plus 17k. And that will be our m cross n.
Okay.
So that will be the answer. So you will try this one. Please put it down. M and n are those. You need to try m cross n, n cross m.
Okay.
Press down.
Yes.
Now you will also try for me this. Show that the cross product of the vectors a and b is perpendicular to both a and b. I hope you know what to do there.
Yes.
So here, what are we doing? You are getting a cross b, vector a cross vector b. Then after, what will you do? After getting this, what will you do? They are saying show that the cross product of these vectors is perpendicular to both a and b. So after getting a cross b, then get a cross b, that vector you have got, dot it with what? Vector a. And see if you will be able to get a what?
0.
A 0.
What of if you dot it with b?
It is also the same also. So also
Okay.
dot it with b.
Okay.
Because you need to show that it is perpendicular to both.
Okay.
So here you have two ways. You can either have a dot a cross b and see whether it will give you 0, or b dot a cross b. For dot product, it is okay. You can have this dot this or this dot that. So what you are looking for here is after getting a cross b, dot it with a, and after dot it with b, see if it will give you what? 0. If it gives you 0, then you conclude that the cross product of a cross b is perpendicular to both a and b. Is that one okay?
Yes. Taken.
Next, that you will try. Find a vector perpendicular to both a and b. What are you looking for there? If they say find the vector perpendicular to a and b, what are you looking for? When they say find a vector, which vector is perpendicular to both vectors?
Either of the vectors.
To both of them. How do we call that? You have forgotten. That is the vector. That is the vector product. The cross product of a and b is perpendicular to both the a and when you get a cross b, this is perpendicular to a. It is also perpendicular to what?
B.
So which means if they say find a vector perpendicular to both a and b, indirectly they are telling you to find the cross what?
Product.
They are indirectly telling you to get the cross product, because the cross product of A and B is the one which is perpendicular to both A and what? A and B. That is what we talked about when we are looking at this one here. Okay. We said that the cross product of two vectors is a vector quantity, but it is perpendicular to both vectors. So when they ask you to get a vector which is perpendicular to both vectors, you are indirectly getting the cross what? Product. The cross product. And it is also similar to this when they say that show that the cross product of this is perpendicular to both A and B. By definition, that it should be true because the cross product of two vectors is perpendicular to both vectors. Okay? Okay. Yes. I hope you will be able to do that. Still, the questions are the same. Now, you will also try for me this last one. Given that A, B, and C show that AB is parallel to BC. If you recall what we talked about, are you done with that one so I can take you there? Yes. If you recall what we talked about here. So what are you supposed to do for that question? Find the cross product. If it is 0, then they are parallel vectors. Exactly. That is what exactly you are supposed to do. So you are told the points A, B, and C are given, show that AB is parallel to BC. So you are supposed to get the cross product of which one? Which ones are you crossing? You cross you cross AB and BC. That is clear. You are crossing AB with you are crossing BC. AB with BC. And if you get a 0, if AB cross BC is 0, then AB is parallel to what? BC. Is parallel to BC. That is what you are doing. So it means you need to first get AB, which you know how to get. Then you also get BC, you know how to get that. Cross the 2, and after crossing the 2, then see if the cross product is 0, you give the conclusion that AB is parallel to BC. So, hey, you still have one more there. There is another one for you. You still have many questions to try. Okay. If vectors P is that, Q is that are parallel, what does that one imply? Their cross product is 0. Their cross product is 0. So get the cross product, equate it to 0, get the values of what? A and B. Of A and B.